OpenTelemetry is the game changer here because it's basically created a lingua franca for observability. So until now, the way it worked is that if you did a vendor implementation, they would give you an agent to install in your environment, and they were in control of that, and they would collect the data from your system. With OpenTelemetry, you are using an open source technology that you can configure yourself, and you can decide what you want to send, whether it's to a vendor or a third party, or collect it yourself and analyze it yourself using open source tooling.
Hello, hello. I hope you are learning a lot here in this fantastic 2022 JavaScript Global Summit by Geekle. Personally, I have been learning a lot here. You know what? Let me know in the chat which are your favorite ones so far in this summit. It's amazing. My name is Manuel. I'm tech lead at Building League. Building League is a leading platform that helps with property management. I also live in Canada, but I'm originally from Dominican Republic. I hope you have visited the beautiful beach of my country, and if not, I'm inviting you. The whole year is summer. So yeah, great. Now let's move to our next blog. Our next speaker is Gadi Raymond. He's a passionate senior software developer at Wix.com. He's focused on architecture, design, microservice, testing, DevOps, and he's here to talk about full stack testing. So let me invite Gadi to this conversation here.
My name is Gadi Raymond, and this is Full Stack Testing. Before we start, a little bit about myself. I'm a tech lead at Wix.com. I've been a full stack developer for around 10 years now. My main strength is backend, but I do also front end. Right now I'm doing React.js, and in the backend I'm doing Node.js and Golang. I really love testing, and this is why I'm doing this talk to you right now. So in the next 30 minutes, I'm going to cover some few things. What are we testing? We will see the evolution of testing over the years. I will show you how to write a test, some best practices, and examples of front-end, back-end, and E2E tests. Hopefully, after this talk, you will be able to improve your testing skills. Also, it will give you a push to set standards in your team, so anyone around you will be better at testing. Also, it will make you love testing and encourage you to read more about testing, maybe practice TDD or other advanced topics which I will not cover here today. So what we are testing? So basically there are three categories of testing: unit testing, integration testing, and end-to-end testing, also called E2E tests. In unit testing, we test the basic stuff. We test like functions or some base functionality. In integration test, we test integration between a few components. So for example, if I have a REST API and I can test the REST API endpoint, usually REST API integrates with databases, external or internal services, message queues, etc. And E2E test usually test the entire flow of our system. So for example, if I have an e-commerce website, I will test the add to cart functionality, also the checkout functionality. So back in 2012, Martin Fowler, which is a famous software engineer, published a post. In this post, he suggested this test pyramid. So we said that you should invest more on unit tests. Unit test is the base of the pyramid, and you should have as many more unit tests in your system because they are really, really fast and really cheap to develop. After unit tests, you should add fewer integration tests because they are a bit slower, and they cost you more because you need to have all the components of the integration tests running. And in the top of the pyramid, you should have fewer E2E tests because E2E tests are very, very slow. They cost you more because it's really, really hard to write good E2E tests because usually they are flaky and can break. A few years later, we started to have more voices like this. This is Giuliano Rauch, one of the creators of Socket.io. He said that you should write tests, not too many, mostly integration tests. So here's an example of why you should have integration test over unit test. So this is this lock is the unit test, it's working, and then comes the integration test and breaks everything. Yeah. So a few years later, Kenzie Dodds, which is a famous person in the front-end world, said that forget about the pyramid. He suggested a trophy shape. And in this trophy shape, the base is static tests. Static tests are like if you have a TypeScript application, the compilation of TypeScript to JavaScript is checking actually your type. And this is some sort of test. Also, if you have JavaScript, you use ESLint. ESLint rules actually also test your code. After it, he suggested that you should have less unit tests and more integration tests, just like Giuliano suggested. And in the top of the trophy, you still need some E2E tests, but not too many. But why actually we need E2E tests if they are so flaky and so slow? So Kenzie Dodds also says that the more your tests resemble the way your software is used, the more confidence they give you. And this is an important part of E2E tests because in E2E tests, you simulate how your customers or users are using your system. Also, in E2E tests, there's no mocks. This is the real thing. This is your real product. So this test is very, very important. So let's start writing tests. This is the basic structure of test, AAA. The first A is arrange. You should arrange your data. And the second part is act. In act, you are calling the system under test. If it's a unit test, you will call the function. If it's like a REST API, you call an endpoint. And the third part is assert, where you validate and check that your response is as expected. Let's see an example for it. So we have add numbers function here, which gets two numbers, A and B, and adds them together. My test should return the sum of two numbers. And the range part is setting variables of 3 and 4, but the act part is calling add numbers, and the assert part is to check that the expected result is 7. Let's cover some best practices. So good tests are deterministic, meaning a test always returns the same output for the same input. Let's see an example as we see here. We have a test and the test have input A. So input A returns output A. What if we run this test again with the same input A and it will return output B, which is different than output A. In that way, our test is not really good. This is a sign of a big problem and we need to fix our test. Usually, we'll get these problems when we're having like E2E tests, which are very complex and have many external dependencies and parameters that affect the test. So it's a very hard challenge to have deterministic E2E tests. Good tests are stateless. Each test is independent from another. Let's see an example for it, why it is so important. So let's see the add numbers example again. So in this example, we have a variable called counter, and the counter is set to 0, and this counter is a global variable for both of those tests. The first test should return the sum of 3 and a counter. So we have a variable called A, which is set to 3. The counter, I will increase it by 1, so counter is 1. We're calling add numbers, so 3 plus 1 is 4. After it, there is another test, should return the sum of 2 and a counter. So we have 2 here, counter increased by 1, so counter is 2 now. So 2 plus 2 is 4. At first sight, it looks like a legit test that should work. But what if I tell you that no one guarantees that the first test will run before this test? What if the second test runs before it? So both of the tests will break. So don't depend on shared state between tests. Good tests test positive, negative, and invalid flow, and don't just test the happy flow. I see it in many cases where people just test the happy flow and forget about negative and invalid flow. And in my opinion, negative and invalid flow are the most important flow to check, because usually that's where the bug is. So divide by numbers, let's see an example here. So I have a function called divide numbers, and it gets 2 numbers and divide them. The first test here is a happy flow test. It just divide number 4 and 2 and expect it to be 2. The second test here is a negative flow test. Should throw a divide by 0 error when second number is 0. So as you know in mathematics, when you divide by 0, this is illegal operation. So I expect when the second argument is 0, that it will throw cannot divide by 0. And also there is the third test here is invalid flow. Test should throw an error when one of the arguments is not a number. So we have a 2 and the second argument is a string. So in this case, I expect that the argument, it will throw an error, argument must be a number. So in this example, if we are using TypeScript, it can we can avoid this test because it won't pass the TypeScript compilation. Having your test run locally is not enough for keeping code quality. Run them in the CI. This is a very important point that I want to mention here. So I really suggest that when people open a PR and want to merge code, then run all your tests in the PR, and only if all the tests are passing, you can merge your code to the main branch. That way you can keep your code quality. Also, set test high coverage as the CI processor runs. This will ensure that people will write tests to their code. If someone is writing code without test, it will decrease the code coverage and hopefully break the CI, and you won't be able to merge the code. Also, if you have slow E2E tests, don't add them to the CI. It will slow the CI process and really damage the developer velocity. So if you have slow E2E tests, run them periodically outside of the CI. It's also good for monitoring your system. So now we can test everything, and let's see testing in the backend part. So we will see an example of a REST API test. So when you have endpoints of API, make sure to test them from the outside. Here I will show Supertest, which is a very useful NPM package. Also test with the little mocks as possible. Anytime you use mock, this is something that you're not testing in your code, so really try to avoid it. Test status code, it's related to the happy flow, invalid flow, negative flow that I told you before. So happy flow can be a status code of 200, a negative flow can be status code of 500, and invalid flow can be status codes of 400. So make sure you test them. Test your business logic. This is an important point because this is the stuff you want to focus on testing. And test with mock data from the DBs. You can spin up DBs in your CI and locally using Docker. And this way, your test will resemble your production. Okay, let's see some code. So this is by full stack repo. I have here services directory with my app, which is a front-end application, and my server, which is a backend application. So let's see my backend here. This is an Express server using TypeScript, and the Express server has two endpoints. One is post, posting and creating a new user, and one is get, getting a user by user ID. Let's see, they're both using a user service, and in this user service we have add user. Let's see what add user is. So it gets first name, last name, and email. Then it's called super complex Bitcoin calculation. So this calculation is basically using random here to get a random number between 0 and 10. And then I'm creating an insert SQL query. And I'm using here Postgres to save the data. So I'm inserting to Postgres. And in the get user, I'm getting a user ID, querying it from the DB, and just fetching it from the DB. And in case where there is no user found, I will return 404 user not found. So let's see how we can test it. So here I'm using Supertest package, as I told you. I'm using here request as an import. And this is the post of users. The first test is the happy flow test, should return a new user for a valid request. So this is my range part. I'm arranging the data, first name, last name, and email. My act part is calling the endpoint, the post with the data. And this is the assert part. I'm expecting it to be the first name, last name, and email. Expecting the ID to be a number greater than 0. And expect the Bitcoin to be greater than 0 and lower than 10. This is an example of invalid flow test. So it should return bad request when missing required first name in the request. So this is my range part without first name, and I expect it to return 400. Here is another invalid flow check. So here the email is not valid, as you can see here, and I expect it to return 400. Let's see some negative flow check. So should return internal server error when Postgres throws an error. So in order to do so, I use just a fan to do some mocking on the Postgres query method. So anytime the Postgres query method will call, it will return an error. Let's see it in the code. So when I'm using it here and when I'm inserting the query, it will return an error, throw an error. So in case of an error, I expect it to be 500, status quo. Let's see the get now. So in the get, again, in order to arrange, I can insert data to the DB using my previous post. So I'm using this post and inserting a new user. And I'm using the post response in order to get the ID of the user, the newly created user. And then I'm using the get. This is my act part. And I'm just validating that the get response is as the post response. Another invalid check here is to check that I get better request when user ID is not a number, expected to be 400. And I can check that user not found 404, or we just give it a dummy ID. And also, like before, when post will throw an error, I will expect it to be 500. So this is the backend part. Let's see the front end. So in the front-end testing, you can test unit and integration test. Unit test is testing like a small component, and you can have integration test when you test an entire page which have multiple components inside. And basically, you're testing your UI and interactions. It will really couple to your front-end framework. So in the example I will show you, I'm writing in React, and my tests are coupled to React. They won't work on another framework. And when you test your front end, mock your backend. You're not testing your backend, you're testing on your front end, so make sure to mock anything related to your backend. And I'm using here testing library, which is a very powerful set of libraries. They have all the major framework there, testing library for React, for Angular, for Vue, even for Cypress. I will show you an example for it right now. So going back to my code, now I will show you my app, which is a Create React app. And let's start with an example of testing library. So this is a grid component. In a React, a component gets as argument something that's called props. This is a name of which type of string, and it returns something called JSX. JSX is a combination of HTML and some JavaScript. So in this case, it will return a div with hello and the name. Let's see how we can test it. So here I'm using testing library React, and my arrange part is to have the name. My act part is to render it using the render from testing library. I'm rendering the component. And then my third part, I'm using screen here, screen also from testing library, to get the element from the DOM and the element with hello name. And I'm verifying that this element is inside the DOM. Let's see a more complex component. So this is user details component. It gets as props user ID. And in user ID, I'm fetching the data from the backend. And I have a variable called show details. Show details at first set to false, and when it false, it will present this title. User ID details is hidden. We have here a checkbox. If you click on the checkbox, it will set the user details to the show details to true, and then we'll present the user details, hello, first name, last name, email, and the Bitcoins number. Let's see how we can test it. Okay, so here I'm using MSW, mock service worker package. It will help me to mock the server. As you can see here, I'm using setup server. So anytime I'm calling the get for my backend, it will return 200 and some mock user that I created. This is the mock user, and I have my name, email, and 5 Bitcoins. Let's see how we test happy flow here. So show display no user details when checkbox is unchecked. So I'm generating a random user ID, render the component, and I'm verifying that user details is hidden. As you can see here, when show details, the first time it renders, show details is false, so I expect it to be in the DOM. My second test is to display user details when checkbox is checked. Now we want to click on the checkbox. So this is the user details title, which is displayed only when show details is true and only when the checkbox is checked. So the first time I'm rendering it, I expected not to be in the DOM, to be null. After it, I'm using fire event again from React testing library. And I'm using the click operation here, and I'm getting the element of the checkbox using regex here. And I'm clicking on the checkbox. This is what this line is doing. And then I'm verifying that the user details title is in the document. And I'm verifying also that hello, first name, last name, email, and the number of bitcoins is in the document. As you can see, I can check negative flows here. What happens if my API returns 500? So I can override the mock that I did and return 500 from the backend in this test, and I expected to have 500 message. Also, what happens if my API returns 404? Again, the same thing, I'm overriding the mock to return 404, and then I expected to have a 404 message. So this is the front-end testing. End-to-end testing. So end-to-end testing is testing your application from the client point of view. It's agnostic to your front-end and back-end framework. It doesn't care that I'm using React or Express. As I said, it's slow and flaky, but it gives you the most confidence, as we saw in the tweet. You can see that. And also make sure to test only your critical flows because they are really, really slow. You don't want a slow build time. Let's see an example of end-to-end testing using Cypress. So I'll first show you the Cypress console here. Let me run this test again. As you can see, it really, really runs fast. And what's really, really cool about Cypress is that you can see each step of the test and the reflection in the UI. So here I'm getting the first text box, typing my name, as you can see here, typing my last name, and really clicking on the submit button. And then I'm seeing a call to the backend, the create user, the get user, and I'm seeing here the user is hidden, and then I'm seeing the checkbox, I'm clicking on it, and I'm verifying that the name, email, and number of Bitcoin is valid. If I run it again, you can see that I'm getting another other number of Bitcoins because this is actually calling my backend, and each time it gets a random number of Bitcoins. So this is my end-to-end test. Let me show you really, really quick the code of Cypress, and just to give you a glimpse of how easy is it. So I have like interceptor to save the create user, the post, and the get user, the get. And this is how I navigate to a page. We have all sorts of selectors to get the element and type them and clicking on elements. This is me waiting for the create user post to end, to waiting the get user will end. And then this is me clicking on the checkbox, validating stuff. And here I'm using the interception to get the response of the get so I can validate the correct number of Bitcoins is there. So let's sum things up. What to test when testing your front end, you test your UI and interactions. When testing your back end, make sure to test endpoint from the outside. And it will test only your critical parts. And when writing tests, write mostly integration tests. Follow the AAA, arrange, act, and assert. And good tests are deterministic, stateless. Test all the flow, not just the happy flow. And really, really important to run them in the CI. So thank you very much. I was Gadi Raymond. If you want to reach me, feel free. This is my email. And all the code I show you is inside this GitHub repository. Thank you very much.
Hello, hello. Gadi, amazing presentation. Definitely testing is something to have in the top of our head while coding, right? And of course, set our CI to run them in automated way is almost mandatory. So yeah, definitely great presentation. So yeah, let's move on to our next speaker. Our next speaker is Raymond Camden, Senior Developer Evangelist at Adobe. He works on the Document Service API to build powerful PDF demos. He's also the author of multiple books on web development and have been actively blogging and presenting for almost 20 years. So you can imagine the amount of knowledge Raymond possesses, right? And he's going to talk about a beginner guide to wrangling asynchronicity in JavaScript. So let me bring Raymond here to the stage. Hello, Raymond.
Hello.
How's it going?
It's going all right. I don't think I have a lot of knowledge. I have a long history of really bad mistakes.
Great. I know you have that knowledge, even with experience, but yeah, definitely. Thank you. So, Raymond, the floor is yours.
Cool. I will take it away. Share screen. Yes, share and booyah. Hi. All right. I am assuming that y'all are seeing what I am presenting. I will say that this is an hour-long presentation that I cut in half. And by cut in half, I meant I took it about 3 slides. So this is going to be fun. Welcome to a beginner's guide to wrangling asynchronicity in JavaScript, also known as why can't things just be easier? I've been using JavaScript since it came out in Netscape Navigator as live script in, I think, 93 or so. I've been using it for a long time. I think I'm almost okay at JavaScript. That's my end goal, is to be okay at JavaScript. So just real quick, I am Raymond Camden. I work at Adobe. I'm not talking about anything I do at my 9 to 5 today. Not going to be showing any PDF demos or anything like that. But because I will be going a little bit faster than normal, I absolutely want you to have a way to reach out. So I blog at raymondcamden.com, and on there is a nice contact form where you can reach out. I also tweet at Raymond Camden. I tweet a lot. I will just warn you ahead of time. You can totally ignore me, but my DMs are open. So if you have a question about what I showed today, or about JavaScript, or about cats, definitely, please reach out. I do not mind your questions. That's why I'm here. So what we're talking about today is we're going to explain what the problem is. We're going to talk about solutions, and we're going to iterate. And essentially, we're going to describe a problem, look at how we solved it a while ago, look how we solved it a little bit better, and then how it's gotten better and better in terms of how we can address the problem. And that problem is, and just real quick, if you want a copy of the slide deck, it is up on my GitHub repository at cfjedimaster/async-presso. The slide deck is pretty much the only thing in the repository. All the code demos are up on CodePen, but the slides give you quick and easy access to that. All right, so the problem. So you've probably written code like this before, where you call a particular function. In this case, it's getCats, and then you need to work with the result, and you get undefined. And you know that getCats is running because you put some console.log messages in there. You see it running. So like, what the heck? Why is this undefined? Well, the reason is that we had this expectation, right? That we would call the function and that it was going to return a result that we could work with. What really happened is that getCats took time to process, and our code didn't wait for it to finish. It just expected an immediate result, when in reality, getCats was taking time. Now, typically, this is something like a network call. So we're hitting some backend API, waiting for it to return, and then returning the result of that network call. But there's other operations that can take time as well. So you shouldn't feel too bad about that. jQuery was extremely popular for a long time. Heck, it's still really popular. And jQuery made a lot of things really easy, right? And one of those things was working with network calls, Ajax calls. So this is a kind of a simple example where I'm calling a URL and I'm passing data and I'm working with the result. And looking at that, it may not be very obvious that this is actually asynchronous. You may just think that, okay, it's this URL, this data, and do this, and it's going to execute immediately. But what happens is that you may say, you know what, let me add a loading message so that, while we're getting the weather, I'm showing something, and I'll write code like you see on screen there, where I tell my user I'm loading, I call load weather, and then I immediately work with the result. This is also not going to work. It's not going to work because it is an asynchronous method. And again, you'd be forgiven for not really recognizing that by just doing a quick look at what load weather was doing. So there's a lot of solutions for this. And the first one we'll look at is one that actually jQuery was kind of using, but not perhaps not as obvious, and that are callbacks. So a callback follows a kind of typical pattern where we have some particular function and it takes arguments. It may take one argument, it may take two arguments, but it will always take a final argument that is a set of code that we want to run when the particular thing is done. Typically, it will look something like this. So I have some API. I'm passing two arguments, a zip code and a type of forecast. And then I'm passing a third argument that's actually a function. This is my callback function. By just, everybody kind of agreeing, the typical way that a callback looks is that it will say, if there's any error at all, it's going to be the first response, or I'm sorry, the first argument. And the result of my operation will be the second argument. So typically when you see a callback, it follows this format. And almost always there's code that says, if error, then do something, and then work with the result. This is how a callback looks. Let's look at an example, and that is incredibly small. So I'll make that a little bit bigger. All right, that's beautiful. Okay, so I have a function, get cats, and it takes a breed and a callback. So I'm passing a breed, a Persian, and I'm passing a callback function, which basically says take the result and display it. In this case, I'm not worried about an error. My callback is not using it. You don't have to always follow that format. In this case, I'm just assuming everything is going to work out, and that typically works all right, right? But again, call my function, pass an argument, and then work with the result via the callback function. So relatively simple, and this was popular for a very, very long time. But what if I want to do two things? Or what if I want to do two things where it's important that I do the first thing first and the second thing second? All right. Or maybe it's okay if I do two things and they can both fire off at the same time, and I just want to know when both are done. Well, you could get a bit fancy. So in this case, I'm calling a method, getCats. It takes a breed and a callback function. And when I get that result, I call another function that takes a callback. It's called getDogs. It takes an argument of what type of dog I want. I do have a lovely dog, and her breed is absolutely stinky. And that has a result as well. In this case, I now have two variables, cats and dogs, that I could work with. So as an example of this kind of working together, what I did was I called getCats. That's kind of on top. I passed a Persian, and I said, when you're done, I then want to run getDogs. And when you're done, use a callback and work with dogs. And then I have both of these together. And that ran very quick. Let's rerun this so you could see. It should take a total of 4 seconds because I am calling one after the other. So this is sequential. It works. All right. But then, one day I decided to get clever. All right? I didn't like those callbacks kind of wrapped in together. And what I did was something like this. Let me kind of highlight the lines here for y'all. So I called both get cats and get dogs at the same time. And in both of those callback functions, I said, hey, get cats, you know what? If the other person's done, if dogs are done, then let's run a function that I could do when I know I have all my data. I did the exact same thing for dogs. Get my result, and I check the other one and see if it's done. Then I call display results. What's nice about this is that these can both run synchronously, and we should see, and I'm not sure how well it'll work over the streaming platform, but instead of taking 4 seconds, now it took 2 seconds. And I was doing two things at once. Computers are pretty good at that. So this works, but it really, really kind of feels a bit brittle. I wouldn't want to go crazy with that. For example, what if I want to do 4 things? I could try, but it's probably not going to scale very well. Here's another way of potentially handling it, where I have 4 methods: get cats, get dogs, get more cats, and then get even more cats. And you can see it's kind of getting more and more and more deep. It's getting a little bit crazy. I have a word for this. It's called callback hell. And if you Google for it, you'll find a lot of people talking about how bad it was. And I agree, it can be an issue. I can say that in my experience, I've rarely needed to have 4 levels of callbacks. I have had 2 before, and I feel it's okay. As developers, one of the things we like to do is make a big deal out of things, and in the real/practical world, it's not always that big of a problem. But people do run into this, and you do want to kind of avoid it. So luckily, we have a second solution, a much more fancier one, and that's called promises. So a promise is an object that represents what your asynchronous code is doing. All right. So imagine if I had a way of asking someone to help me and say, hey, I ordered some pizza. Would you mind letting me know when the pizza is ready? And I may bug you a couple times and ask you directly, but I want you to keep track of that so that I don't have to myself. Now, a promise can actually have 3 different states. Pending means it's still working. Fulfilled means that it's done. And rejected means that something went wrong. Let's look at the code way of looking at this. And you can also chain these too. And I'll be showing a couple examples of that. So we're still working with get cats, except this time we have updated get cats now to return a promise. Notice that I changed my left side from result or cats to cat promise. That is an object. And once I have that object, I can add a function to it, or I can add a property. In this case, it's then. And I'm saying when the promise is fulfilled, this is what I want you to do. So in this case, the promise, when it is fulfilled, it's always going to pass whatever the result is. And you can see that I'm working with it here. And one kind of cool thing about promises and the then API, it doesn't matter when you specify this. If I had 1 million lines of code between 2 and 3, and please don't put 1 million lines of code in your JavaScript file, but if I did, the then API is smart enough to say, hey, you know what? You're already finished. I'm just going to run this right now. You just don't have to worry about it. It also handles reporting errors. In this case, I've just added a .catch to it. And typically, all your code should look something like this because all of us error check all of our code, right? I know I error check everything I write. But again, typically, this is what it would look like to work with a promise. The .then basically means, when you're finished, let's work with it. And the .catch is how you would handle anything going wrong in that asynchronous process. So if we look At an example of this, I have two calls. First, I'm calling getCats with Persian, and I'm specifying, hey, when you're done, I want you to use some DOM methods and just write the results of working with that particular method. I'm also demonstrating an error. In this case, I'm asking for a bad breed. In this case, I essentially report the error that came out to me. So nothing too fancy about this. Instead of working with the result directly, I work with the promise object and then just basically specify what to do when it's done. By the way, I'm going to be showing getCats in a little bit. That's kind of what's hidden down here, hidden by the super spy technique of just hitting return a bunch of times. Here's another example where I actually have two APIs that return promises, getCats and getDogs. And what I've done is I've run getCats and I've said, hey, when you're done, go ahead and save that result in a variable called cats. And then I want to return from here another promise. getDogs is creating a promise, and I'm allowed to return that, which allows me to chain, one more .den at the end. When I get to here, when I get that dog result, I know that everything has been completed, and then I can work with the result. So this is synchronous, but hopefully a little bit easier to read than the nest callbacks. If we do rerun this, 2 Mississippi, 3 Mississippi, 4 Mississippi, yeah, you can see it's taking about 4 seconds, which is to be expected. Now you have some cool functions like promise.all, which allows you to send multiple promises in and lets you know when they're all good. And let me just stress, all good. You can use a catch, but that's going to fire on any error. It's going to fire immediately. If that sounds worrisome, yes, but don't worry. I'm going to show a way around this in a few minutes. So as an example of what promise all can look like, I took my two calls, getCats and getDogs, and I passed them as an array to promise.all. So, and in this case, when you use promise.all, the result object will be an array where the first item in the array matches the result of the first promise. The second item in the array matches the result of the second promise. That's why I'm doing cats equals result 0 and dogs equals result 1. This will now run at the same time. And again, this may not work terribly well over streaming, but this should be 2 seconds. 1 Mississippi, 2 Mississippi. There you go. Definitely faster because it's running both at once and firing when they're all done. Now you can create your own promises. I have been doing that for my CodePen demos. I've just been hiding it from you. The API looks like this. You create a new promise object, and in that promise object, you are writing a function that will take 2 arguments, resolve and reject. You use resolve to return a good value and reject to return a bad value. And by the way, you don't have to use arrow functions. This is the exact same thing. You're not using arrow functions. I have a comment about arrow functions coming up towards the very, very end of this, but just know that's not something that you are required to do. So here's a kind of a more real world example. I create a promise object, and then I do stuff. And then if everything worked out well, I'm going to use resolve, and that's right here, to essentially send back whatever I did, whatever process I did. And if something went wrong, I am returning a good, useful error message that describes the particular problem. So this is essentially the exact same CodePen I showed y'all earlier. The only thing I've done is copied and pasted those functions up so you can see how I was creating my own promises. I'm simulating a slow process by using set timeout. That's where that 2 seconds came from. And here you can see resolve. That's where I returned my data, and reject is how I handled my particular error message. And hopefully this makes sense. Now you may be wondering where this would be useful for you. One of the great ways to use new promises is to fix APIs that don't return a promise. So the geolocation API of the browser, it takes two arguments, three, a success function, an error function, and a set of options. It does not use promises. But what I could do is actually fix it by wrapping it in my own particular promise, which lets me use geolocation a bit better. Let's open this up on CodePen, because geolocation does not work via embeds. And let me make this a bit bigger so you can actually read. And there we go. I have a function called getLocation. It's returning the promise. It's wrapping the call to the browser's geolocation. And just note that my code then to use the browser feature is a bit simpler to use because it's promise-based. I can just do getLocation and then .then and then work with my result. I'm essentially building a nicer geolocation API than what the browser itself supports. So some good things that you could do in promises. You have a couple of things baked in. All settled lets you run multiple promises. And if they're good or bad, that's fine. And it will tell you, hey, you sent me 10 promises. These first 6 were good. These last 4 were bad. With promise.any, you pass in a set of promises, and as soon as one good result fires, it will execute. It will tell you that that one good thing has happened. You also have promise.race, which will handle good or bad, and whatever is first will fire. And then you can also do promise.finally and say, hey, no matter what happens, do this. So honestly, I can see all settled being pretty useful. Any and race being more of an edge case. But what I like is the fact that you now have support for any type of thing. So for example, I want to fire a bunch of stuff. It's okay if some error, just tell me when they're all done and let me know each one. Or I'm firing multiple calls. Maybe I'm hitting 2 weather APIs. And as soon as one good result comes back, tell me that particular one. So you have different tools and your tool chest that handles those different kind of scenarios that you need. So here's an example of a browser API that does work with promises natively is the fetch command. If you have not used fetch, it is a way to do network requests that's a heck of a lot easier than native Ajax calls. And in this case, I'm wrapping a call to an API, returning the fetch call. And in my code, I could say, call get Star Wars films, take the result to get the JSON, and then work with the results. So that's pretty simple, but I could make this even better, where instead of returning just fetch, I'm returning a promise. And the reason I'm doing that is because I want my calling code to be simpler. So I handle now getting the JSON. I handle knowing that it has a results array that I really care about. And that's all I return. And now my calling code is basically, hey, get my Star Wars films. And when you're done, let's work with the result and show each one. And what's really nice about a form like this is that if the API is in construction, you could actually mock it. So I'm still returning a promise. My calling code is the exact same, but instead I'm immediately resolving an array of static data, which is totally okay for you to do. So just a lot of resources on promises. MDN is the absolute best web resource out there for anything related to web development. And of course, it has great documentation on using promises, as well as an in-depth look at the API. Our last solution, and this is great because this came out like right when I was getting comfortable with promises, and it just confused the heck out of me, and that is async and await. So this was introduced in ES8, ES 2017, which we all understand, not weird at all. Back in June of 2017, added to Node back in 2017. It is very well supported. If you are not aware of canIuse.com lets you test any browser feature and tell you how well it's supported. So async await, you can see it's green for everything but IE and a few obscure browsers. So a good 96% for all of these in general. So definitely safe to use. It is not a replacement for promises, but more of a promises 2.0 kind of, or some syntactic sugar to make working with promises even better. So I am still learning this. So if I'm making any mistakes, blame me, don't blame the spec. But here we go. So it gets rid of then hell, which really isn't a thing. And it lets you write async code like it was sync. Now, some of you may be saying, oh, it sounds like a foot gun, Ray. You know what? You're absolutely right. It's kind of a foot gun. It's a pretty cool foot gun. Like a lot of really powerful tools, as long as you know what you're doing, hopefully, then it should be safe to use. So let's look at an example. I have get user, which returns a promise. And then in that then, I'm calling another method, get orders for user, which returns a promise. And then when I'm done, I work with something. So that's not too hard to do. I think that's pretty clear. But what's even clearer is the async await example, where in this case, I'm saying, hey, just get my user. And it's a result of get user. And that await is essentially syntax sugar to say, I'm going to wait for an asynchronous process and then work with it. Ditto for get orders for user. So the way this works, so first thing you do is you add an async keyword. It marks it as a function that's doing something asynchronous. It makes a function return a promise even if it doesn't. On the other side, you use the await keyboard to wait for an async function or anything that returns a promise. The await keyword also has to be inside an async function. This last bullet point caused me a heck of a lot of trouble. Hopefully I'll be able to make sense of it for you. So function foo return 1 returns just 1. No big surprise there. The second we add a sync to it, it's now returning a promise. Even though our code's not, it's returning a promise. It's a promise that's already resolved, but I would have to work with it using .then to actually get the result. This is more of a real-world example where typically I want to define a promise to do something and resolve it. And again, that async keyword in front will let me use it with await. So that's the easy part. Now, if I try to actually use it, let result equals await foo. This comes back to that last bullet point where I mentioned if you use await, that line itself needs to be inside an async function. That's weird. So typically you add it to the calling function, but that may impact the function calling it, and so on and so on. It can get a little bit crazy, but I think here's a good real-world example where I have an event listener for DOM content loaded. I mean, basically the page is ready to go. And I'm saying run the init function. My init function, I wasn't really thinking of it as async, but I added async in front, and that allows me to use await in the call to get Star Wars film. If I took off that async there because I'm thinking, yeah, it's not asynchronous, I'll get an error because the minute I start waiting for an asynchronous process, the parent function becomes async as well. A lot of my code though looks like this, wait for the document to load and run init. So adding an async in front of that is no big deal typically. Here's another example where I'm doing two particular calls. I wait for get Star Wars ships. I wait for get Star Wars film. And you can see it's written in a very kind of synchronous manner. Get my spaceships and then write it out to the DOM. Get my films and then write it out to the DOM. It is mostly, I would say, a simpler way and a nicer way of working with stuff. We can get a bit more complex. So for example, if I want to run both at once, I call my functions which return promise. I add them to promises.all. And instead of using .then, I can await the result of promise.all, take those results out, ships and film, and then draw them out. This has the benefit of now being now running both of those calls at once. The previous example, it was calling get Star Wars ships, waiting, rendering, calling the films API, waiting, and rendering. Now it's firing both API calls at the same time, but I can easily await for both of them to finish and then work with the result. So some more async fun. Loops can be an issue. Like for loop is okay, but for each is not, because the way the for each is worked, the way it's architected, it's working with callbacks and not promises. Map will potentially work, but probably not what you want. It's very, very complex. There is a blog post that I have bookmarked and I've linked to from the slide deck, which is probably an hour-long read. And I'll click to open it. That tells you everything about the different types of loops and how to work with them. Essentially, I've bookmarked it. I keep it as a reference. I do have an example here where I'm calling get Star Wars ships with multiple inputs, and I'm just dropping them into a for loop and doing an await on all. And that is, to me, is how I typically would do a dynamic loop with async and await. And I think I'm finishing up almost on time. Some quick last tips, use what makes sense. So I talked about callbacks as the first example, as the old dusty example. Guess what? They still work. You may have a library that's using callbacks. You don't have a choice. You have to use callbacks. That is okay. I am a huge believer in being practical and doing what works best for your team. And then look at slowly migrating code. The fat arrow syntax, that thing bugged the heck out of me. I hated it. I thought it looked stupid. Every time I saw code with the fat arrow, my brain just hit an immediate stop. And I was like, all right, let me translate this to what it means. I was that way for like half a year, and then finally it began to click, and now I like using it. So don't feel like you have to force yourself to use something that's not going to work for you. As an example of just how slow I am, I literally spent a couple hours debugging something where a coworker came over and was like, dude, like scroll down the page, you'll see what's going on. And yeah, so that was, a good 15 years ago. I would like to say I'm much smarter now, but I would be lying to you. So some links, I will say exploringjs.com. Dr. Axel is incredibly intelligent, and he goes very deep into stuff and has a lot of free content. So check out his stuff. Again, MDN, Moz Dev Network, is the #1 place to go to learn new things. And I have a link to my CodePen collection of all the demos I showed. And there we go. I finished on time, mostly.
Okay, thank you, Ray. Wonderful. There are like few things in the web development world that are difficult to deal with, such as like centering a div, naming things, and also like dealing with asynchronous calls. So thank you very much for all this useful information, which, great tips here to deal with asynchronous calls in JavaScript. Thank you very much.
You're welcome.
Thank you. So yeah, Raymond, I will see you later on the QA session. So see you in a couple minutes. Okay. Thank you very much.
No problem.
Okay, so now we have a few words from our sponsor, Influx Data.
Thank you, Influx Data, for sponsoring this event and for joining us as presenters. So basically, if your app or the product that you're working with is using time series data, then for you, this is a very cool solution, because you know that building real-time apps with legacy databases, it can be just a nightmare, as you have to spend more time basically managing the infrastructures instead of shipping the code. But with InfluxDB, the leading time series platform, which was built actually from ground up to handle massive volumes of timestamp data produced by sensors, applications, and infrastructures, InfluxDB empowers us as developers to build real-time IoT, analytics, and cloud applications with ease. And you can easily start and scale InfluxDB, and it will give you the time to actually focus on the features and functionality that give your app the competitive edge. You can focus on things that you are best at and let the InfluxDB do the rest. And you can get started for free today using the link in the chat. So it's influxdb.com/cloud. And don't miss your opportunity to grab it for free right now.
Okay, we are back. A quick reminder, something that I forgot to mention. We will have a QA session at the end of this blog with all the speakers. So please make sure to include your question using the QA tab to put your question there. So yeah, keep that in mind. So now let's move to our next speaker. Last but not least on this blog, we will have Nir Kaufman, and I hope I'm pronouncing his last name right. So Nir Kaufman is a front tech lead at Next Intra. Nir's also community enthusiast, meetup organizer, international public speaker, training, author, and mentor. And he's going to talk about Back to the Future with Backbone.js. So let me bring Nir here to the stage. Hi, Nir.
Hi, how are you?
Great. How's it going?
Great.
Where you are located right now?
In my office.
Oh, nice. But I mean, what country?
Oh, what country? Israel.
Yeah, Israel. Nice.
Broadcasting straight from the heart of the Middle East.
Cool. Perfect. Well, Neil, the floor is yours. So I will let you to present your talk. See you in a few minutes. Bye.
Just my screen. I need my screen. Yeah. Ooh. All right. So, hey everyone. Nice to be here online. And let me share my slides for today. I hope you can see them. Wait a second. Bam. Let me just make sure that you actually can see it.
Yeah, we can see them. Don't worry.
Yeah, you can see it? Because I can't see myself.
Yeah, all good.
And today, for the next 2 hours, we're gonna dive into Backbone.js. It's gonna be a long journey, so get prepared. I believe, it might take 3 hours or so. I'm just kidding. How much time do I get? 25 minutes? Let's get started. I just want to put the camera in front of me so I can see myself and I can see you. I'm going to talk about Backbone. Now, I don't know how many of you, when have you started with JavaScript or JavaScript framework, but long time ago, there was a framework called BackboneJS, and it was very important framework. And today, the purpose of this talk is not like to dive deeply into a very old framework. It's more about getting you a little bit more inspired and open your mind, because I do have a message in this talk, a hidden message that I would like to pass through. First of all, let me start with a quote. There are no bad practices, only trade-offs. This is obviously John Lennon. And we're going to talk about front end. We're not going to talk about back end, because recently I don't believe anymore that there's a difference between front end and back end, or the new hype called a full stack developer. Because at the beginning, long time ago, when I was a young developer, there was no front end developer. There was no back end developer. There were software developers. And if you were lucky enough, or not lucky, depends who you ask, to build web applications, so you've been a web developer. So no backend, no front end. You will have to know everything from the database down to the last row of HTML without any fancy titles. So no full stacks, no front ends. I started with Flash, and Flash technology created by Adobe, or actually by Macromedia. Before front-end developers, we were RIA developers. RIA. It's called Rich Internet Applications. And these days in the community, I ask a lot of people, what actually makes you a front-end developer? What does it mean to be a front-end developer? What is the front? I mean, if you build actions for voice-activated device, are you a front-end developer? What's the difference between a front-end developer and a UI engineer developer? But enough about the past. let's talk about the future. And in the future, in modern front end, and as a reminder, the title of this conference is Life Outside the Major Popular Framework. So I'm not allowed to talk about React, Angular, and stuff. I think we took it too far. I mean, to be a front-end developer today is a complicated thing. I mean, does it have to be complicated? Have we built mighty complex framework that just introduced new problems and now we try to solve them? Like it seems recently that every new library tried to solve problems that wasn't exist before the previous library that introduced these problems. So if you're familiar with KISS, I call it in the front end community, I call it the forgotten principles. KISS stands for Keep It Simple, or this great band from the past, because we are talking about the past. Because back then, build web applications was all about send some HTML to the browser and that's it. So I used to work with Java, and we built complex app, and eventually we had to render some UI. So we sent some HTML to the browser, valid HTML, a little bit of CSS, and we might add or drop a little bit of a line or two of JavaScript just to make it interactive. But that was basically it. No framework, no libraries, no spatial architecture pattern just to build something on the front end. But today we build micro front end from multiple single page applications that we might and we will build with different framework, and that just for a starter. I didn't even start to talk about bundlers and the entire ecosystem. I think that this gives kind of show you how I think about it today. And then a very important moment in time. If you haven't seen this talk, I highly encourage you go ahead and watch it. There's a link, and I'm going to share the slides with you. But this is the moment where React introduced to the world, and I think that this talk is very, very important when you investigate the history of modern front-end development, because right there, he challenged one of probably the most popular back then pattern to build systems that need a user interface, which called MVC. Now, if you're long enough in this business, you are familiar with MVC. Now, I said MVC used to be popular, but I don't believe myself when I'm saying this, because my message to you guys today, and we're going to try to prove it with Backbone, is that MVC is still relevant. MVC is a battle-proof design pattern that actually, and surprisingly, make things maybe a little bit easier in modern single-page application development. So it's not super sexy with tons of buzzwords like component architecture and let's say some more buzzwords, and a reactive state management, and front-end compilers, and Svelte and Quick and Angular and React and you name it, and tomorrow we're gonna get another framework. But it's still there. And in this talk, he challenged MVC because Facebook had a bug. They need to solve it. They come up with something else. React, Redux, Flux, everything started over there. I highly encourage you to look at this talk, because these days it seems that a lot of us doing BDD, which stands for buzz-driven development. I've been a consultant for almost 8 years. I walked around companies and teams over the world, basically. And a lot of times I can hear, yeah, we choose to use this framework and this framework and this library because, well, it's popular. It's going to help us with recruiting. It's going to help us with HR. We want to do it because it's cutting edge. And well, everyone do it. That's the new thing, documentation, community, ecosystem. But at the end of the day, we need to ask ourselves, does buzz-driven development really holds? I created a wonderful, amazing diagram, as you can see. I spent hours just to refine it. to, no, I'm kidding, obviously, just a circle with some words. But this is like the flow that I see a lot around. There's a new library introduced, a lot of buzz, a lot of PR, blog posts, YouTube videos, you name it. And then it seems like everyone uses it. So if it seems like everyone uses it, maybe everyone uses it, so we should use it. And then when we get inside, we ask ourselves, do we really need it? Does the app that we are building actually needs this entire complexity? Can we do it without a framework? All right, let's move forward. Let's see where it goes. I put here some screenshots from just recent posts out there. React, very popular, maybe one of the most popular front-end development libraries out there. And then suddenly, posts like, you might not need an effect, which is one of the kind of new features, kind of like 2 years, 3 years. You might not need Redux, very famous, the post from the creator of Redux itself. And then, why should you use Sass instead of styled component? And then, should we use Vite for React app instead of create React app? And why? I mean, we have a CLI that enable us to build a project in React, and now we've got another CLI, and this one is a little bit faster, but this one is a little bit slower, and this one is a little bit nicer. And I'm tired. I like my job. Two principles that I took from KISS. One of them is Yagni. I didn't make it up. You can look for it. It's called You Aren't Gonna Need It, which thing that I believe that we forgot, which basically says don't add functionality until it's actually necessary. But all of us these days, starting a new project and bringing the entire world into it, even before we need it. Yeah, this GIF, I believe, showed the problem. Another principles that I brought here to my slides before we move to talk a little bit about code is the DTS TTT CPW. Again, I didn't make it up. You can look for it in the internet. You can pronounce it as DTP. And it basically means do the simplest thing that could possibly works. Simple to understand, simple to read, not that easy to implement. Because, well, all of us are very, very, very senior, experienced front-end developers. We learned a lot of tools. We want to bring all of this knowledge to the code. We want to show that we can build complex things. Do the simple thing that can work, and that's it. So what are we getting paid for? Just because it's popular doesn't mean it's good for us. We talk about it. So let's go back to 2010, which is 12 years ago. So what happened 12 years ago? Again, a very, very, very important moment in time. One of them is that back then, PHP developers were literally rock stars. If you've been a PHP developer, you're on fire. Everyone wants PHP developers. The entire web built on PHP, and PHP developers, it's hard to get. Well, that was then. Today is more like this. No offense, but that's life. And BackboneJS, guys. BackboneJS was a framework that I believe it wasn't the first one, but it came out with the concept of let's take a solid non-battleproof pattern called MVC, and let's translate it to JavaScript. Let's see if this pattern can help us build single-page application. So that was a little bit of slides. Let's go a little bit deeper. So I created here, let me just share my browser with you. Yep. I believe you can see it. There's nothing special here, just a single component. I created a React application. I'm not allowed, but that's what I did because I want to talk with you about Backbone. So that's going to be the fastest Backbone tutorial in the world. Hopefully, gonna open your mind. So I'm gonna take a modern project. Now, I choose React, but you can do it with vanilla JavaScript. And actually, I know I'm not allowed to say it because it's forbidden, but Backbone is coming with its own template language. It's not actually a template language, and it's actually use jQuery behind the scenes. So you don't even need any modern library to build your view layer. And another secret, I searched for it through the internet, but I couldn't find it. When React was first released, I don't know if you remember, but the slogan was React is your V for your MVC. So React, the first slogan, the first website was MVC is totally fine, no component composition and stuff. MVC is great, and React is supposed to be a library that helps you implement the view layer in MVC. But that was a long time ago. So I'm going to take this React project, which again can be any framework, and I'm going to do something which I believe you will not see whatsoever. I'm going to create a directory. I'm going to call it models. It's actually going to hold a model. And then I'm going to create another directory. I'm going to call it controllers. If you're old enough in the industry, it might look a little bit like AngularJS, because AngularJS as well was much more popular, but it implemented the MVC, but it was the next step in evolution. It was MVW, like MV whatever. Like you've got a model, you've got a view, you've got controllers, but it's kind of mixed up. So I'm going to create a models directory, controllers. I'm going to create views. And here we go. Here's the MVC. Here's the separation of concerns, the classic separations of concerns, the 3 layers of MVC. If that's the first time that you're seeing this, you can already assume that inside the models, we're going to hold some data. Inside the controllers, it's going to be some kind of a middleware between the model and the views, going to be what we're going to see on the screen, which kind of makes sense. I'm going to add another library, although it's not necessary, but because it's a BackboneJS tutorial, so I'm going to add collections. And let's try to see how it is to actually write BackboneJS code. So in MVC, everything starts with a model. Now, I'm not going to get too fancy because that's not the point. I'm not trying to impress you with like an amazing demo that's going to blow your mind. I'm just going to give you a taste. So inside my models, I'm going to create a class. I'm going to call this class a task because everything starts with a model. It's going to be a task.js. And inside, no, don't add to Git. We don't care about it. Cancel, leave me alone. Inside of it, I'm gonna create a class that represents a task. Now you see that I import something from the library Backbone. I'm importing the class model. I'm extending this class, very object-oriented style, all right? And why do I do it? Because you see here, when I get some helper methods out of the box, like this save. So I can save and I can get from my model, which implement getters, setters, and a lot of good stuff behind the scenes. So now that I've got a model, I can create a collection of tasks. And the beauty about collections in Backbone is that, another nasty word, be careful, not just MVC, I'm going to say RESTful API. Because these days, GraphQL and other protocols, and no, let's just talk about REST. So tasks.js, and inside of tasks.js, I'm going to write down this code. Let me go through it with you. I'm taking a class called collection from Backbone. I'm going to use the model, all right? And this is interesting because you see I'm initializing a URL, and in Backbone, there's a very, very, very high level abstraction on top of RESTful API. So basically, you see these methods, this where and this where. This is all the boilerplate code that I need in order to communicate with this endpoint. So right now, I've got queries. I can post, I can get, I can delete, and it's aligned with the protocol. So I know exactly what to expect from it. Of course, you can customize it, but basically, another simple class, which is nothing more than a collection of tasks. All right, so we've got our model, we've got a collection of it. Let's move toward the controller. Now, because it's React, I'm going to build a modern controller with Backbone. This controller is going to be implemented as a hook. I'm going to call it use tasks.js. Let's explore the code. This is a React hook, a simple function. But here's the magic. I'm using the task collections that I created before, and the task collections comes with API that enables me to listen to changes, and I'm listening to the add event, and when I get the add event, I'm gonna set the tasks, and that's it. Now, if I want to fetch them from the server, again, task collection dot fetch built in inside BackboneJS, high level abstraction over RESTful API, and that's it. So yeah, it's a tiny demo, it's a very naive code, but it's just to give you a sense how it feels like to work with MVC. So I've got my model, I've got my collections, I've got my controller, which is the middleware between the view, and then the only thing that I need to implement is the view. And inside of React, a view is a component, a very, very simple component. Again, no Redux, no state management, no store. Let's call it tasks.js. And here is my view. Let's look at it for a second. So I'm using the controller. The view knows about my controller, so I'm using the task controller. If I want to add task, I can create an instance of my model and push it to the collection. Everything else is gonna work out of the box. And then I can map over them and show them in the browser, which means that technically speaking, if everything okay, you should be able to come here to my app, and let's add the tasks component. Yeah, from views. And reactivity worked. Yeah, probably. I don't see any reason why not. And actually, just for the fun of it, let's go to the collection and try to, the controller right here, and try to use the test collection fetch, and then call set tasks. See if I can actually fetch it from a remote server. It might work, I don't know. No, he didn't. I missed something. Maybe proxy or stuff, I don't know. Failed to load resource. Yeah, the server response not found. All right, so forget about it. So what's the point, you might ask yourself? Why does this strange person talking about unpopular opinions show us some code of old people that started with JavaScript like 20 years ago or so? Why? Because, listen guys, you can build a production grade application using the MVC pattern, which might be much more simpler mental model to work, because, and that's the huge secret that no one's don't want to tell us. Most of the systems that we build are basically simple. Most of them are crowd applications. Most of them, not all of them, there are some very unique stuff out there. But in most of them, we can use MVC that's actually going to be much simpler to us instead of handling reactive state management. And in most of them, a RESTful API would be more than enough. But shh, don't tell anyone. So this is how 2022, almost 2023, React app that use the MVC pattern might look like. If you're curious, I highly encourage you to revisit the past. Go to Backbone.js. Go through the tutorial just for fun, just to get this feeling of back then when we were younger, things was much simpler than today. All right, so let's summarize, because summarize it's important. It's easy to add complexity. It's hard to reduce it. Don't add complexity. I know, super unpopular. Choose the simplest tool that's right for the task. Start with the bare bone minimal project. Don't tell to yourself, one day it's going to grow to 1 million users, so I have to use this and that and that. And maybe not. It might not grow to 1 million users. Maybe after the first 2,000 users, you'll decide that you want to build something else. That's life, right? Very, very important message. In Hebrew, we call it hachana lemazgan. And I don't know how to translate it, but ask if you've got a friend that speaks Hebrew. Next tip, use 3 layers of toilet paper. That's a game changer. 2 layers is not enough. MVC got 3 layers. I live in MVC each and every day. 3 layers. Well, basically, I think that's it. I had my introduction. So these days, I'm acting as a front-end tech lead at the Next Insurance. If you want to learn more about me, you are more than welcome to use my simple website. Again, super simple, don't need the complexity, Nir.life. You are more than welcome to keep in touch in any channel or any media. And follow up. Next month, I'm gonna travel a little bit around the world in some conferences. If you're around, come and say hi. Yeah, and this is me in the picture, but that's life. Where's my host?
Hey, Nir. Wow, interesting point of view about Backbone.js. I used to use Backbone.js I was in the university. It was just for one project. But as you mentioned, like then the world of React, Angular, Vue came up. So, people switched to those modern frameworks. And Backbone was left behind, like in terms of, of users.
Mm-hmm.
But yeah, definitely things in the past were simpler than we have right now.
That's life. But I say let's bring it back.
Yeah.
Nice. Be brave.
Cool.
Right then.
So now let me invite the other speaker and move to our Q&A session. Let me.
Where is it? Same.
Here. Stay here. Yeah, stay here. Don't move. Let me add Raymond and Gadi. Here we go. Okay, cool. Hi, Gadi.
Hi.
Great. So let me see from our. Let's start with this one for Gadi. Here we go. Gadi, based on your experience, what is the test coverage threshold you would stick with?
Yeah, so you can see in many posts online that 80% code coverage is like the golden trophy, and I try to do the same, to do at least 80% of test coverage. There are people I know that are fanatic about test coverage and trying to accomplish 100% test coverage. But most of the time when you try to get to 100% test coverage, you're actually tweaking stuff and doing special things just that your test coverage will increase. And this is not very healthy in my opinion. And I think if you have around 80% and more than 80%, that means that you are covered. And again, you can have like 95% and your tests are not very good, and you can still have some bugs that slips. So if you see my talk, follow the best practices that I told you. and test not only the happy flows, also the negative and invalid flows, and try to achieve 80%. And one more important thing is like to add a test coverage threshold in your CI. That way, if someone don't write tests, it will decrease the test coverage, and hopefully your CI will catch it, and it will require them to write tests. So yeah, in my teams, I try to get to 80%.
Same here. Like on my team, that's the number. What we call it the magic number in terms of how much test coverage we need to include. Because like below that, it seems not enough tests, and above that, it seems like too much tests, and probably you are including things that you shouldn't test.
And the last 20% we test in production.
Great, cool. So I have one for Raymond here. Let me open it here. So for Raymond, could you please explain how does asynchronicity works in JS, since it's not multi-thread language? Some people have told me that JS is async is fake because of that.
Sorry, like the second you began asking that question, two of my cats just ran in arguing. There's peace now, but yeah. So my understanding that is that's using the event loop, which is basically processing what it can when it can. That's as deep as I get, and I don't worry about it, to be honest. Is it fake? Is it real? It is what it is in terms of how you deal with it, and the fact that you can do multiple things at once from a practical impact will impact you in terms of how you build an application. So a lot of the demos you see out there are doing one API call, and there's nothing wrong with that. Like the typical thing is on page load, call an API, get some crap, render it on screen. Nothing wrong with that. The things that I worry about, the techniques I worry about, is when it's, I have in network calls. I have any random number of network calls. Then I begin thinking about the ways of handling them at the same time. So I'm not doing it sequentially by accident. That's one of the things that I think, even when you begin to learn to handle asynchronicity, you still have to kind of plan how you're going to handle multiple calls. And we have options for that, which is good. Sequential is not always bad. Sometimes it's required. But again, I kind of focus on knowing this is how I do synchronous async. This is how I do multi-async at one time. I have those tools, and I have to think about it when I'm building my application. That was kind of a non-answer, but kind of an answer. Hopefully that helps a little bit.
Yeah, cool. Yeah, definitely. Okay, I got one here for Nir. Let me see. So Nir, the question is, which testing library would you use for BackboneJS?
With BackboneJS, first of all, I don't use BackboneJS. That's I don't use it not because I don't want to use it. I don't use it because we don't use it for the exact same reason that I just mentioned. But probably because BackboneJS is very, very, very JavaScript plain thing. I believe that every testing framework or library would work. And generally speaking, when people ask me which testing library, which library you will use, I know it's a very tricky answer, and I don't want to say it depends, because it's not depends. I'm choosing the library that I feel more comfortable with. I believe that a tool, a library, a framework should be transparent as possible. So each one of them got its pros, its cons. Each one of them got these features and these features, but by the end of the way, all of them will do the work. And it's important to just pick up on something that you feel comfortable with and fly away.
Now I'm curious, like, what's your what framework do you use in a daily basis? Usually, like, if it's not BackboneJS.
Well, usually it depends. In my company, we use Angular and we use React, and we use React Native for some of our apps. My simple website built with Gatsby. I've got like my own weekend project which I built with Flutter, and I'm currently working on another nice community project which I built with Next.js and React. And actually, these questions that you ask, it's one of the things that I would like to say, to especially to junior developers, but not only. I mean, when you use as much UI frameworks as you can contain, you learn a lot about frameworks. You eventually you see that just like testing library, all the frameworks solve the same problem, each one of them from a different perspective, and then you can see the framework within the frameworks, and then there are no limits. Just choose whatever you like and dive in. But yeah, so I'm using multiple UI frameworks.
Cool. Nice. Great. So now I have a question for Gadi. It's a big question, split in two parts, but let me open the first one here. So let me read this one. So how do you find balance? Should you attest to each API endpoint status code test, for each function unit test, for each action end-to-end test?
Yeah, that's a really good question. It's a very hard question because it really depends on the use cases. And when I try to think about how much test do I need, I really try to think before of what's the most important thing in my application. Is it the front end? Is it something that shows a very sophisticated graphs, and I need to do some sort of slicing and dicing the UI and showing all those cool things? Then I will focus on my front end. If I have a very complex logic in the back end, maybe algorithms or things like that, I will focus on my back end. And as I said in my talk also about the E2E, the E2E should focus on only your critical flows in your application. I see many cases where people just love to write E2E tests and write many E2E tests. In my last company, I think they had a whole department of automation developers, and the E2E tests took like a whole weekend, like 3 days running E2E tests. And then in the end of the weekend, some poor developer opened the test results and saw how many tests got broken. So you should have a balance in your A2A tests. You should have a balance in your every kind of test. But I usually love integration tests because and not so many unit tests, because I tried it in my integration test. They will include the part that I want to have unit test on.
Great. So yeah, and there's a second part. He asks, should each React component should have a test, when to stop, what's enough?
Yeah, and again, it's really related to the integration or unit test. Like if I have a React component that includes many small components inside, I will try to have a test on the parent component, and then I will include all the inner component inside. And really depends if the component is like dumb and all it does is like displaying stuff. I don't want to test it. It doesn't worth the time of writing the test and running it. So yeah, it really depends if this component is like a crucial part. Then I will focus on testing it.
Great. So it will be case by case.
Yeah.
Not a general rule. Nice. Cool. So guys, I think we finished with all the questions. So thank you very much for your time here. We learned a lot from each of your talks. So yeah, definitely hope to see you again soon. Probably on the next conference here. So thank you very much.
Thank you for having me.
Thank you.
Thank you very much.
Thank you. Nice. So now we'll handle the talk to our next CM. Let me see. Yeah, it's here. Maria Villa, who is here to handle the next block. So Marian, Here we go. So thank you very much here for having me, and see you on the next one.
Thank you, Manuel. Bye-bye.
Bye.
So hello, Geekle community. I'm here, super happy to be here to present the next track, the newer track. So today we have like a Deepa Subramanian. She is a QA developer on Adobe, and she is going to talk about building UI component using Storybook.js. So I'm pleased welcome today to Nadia. I'm going to introduce Nadia here after the break.
Yeah, we'll have a break. So yeah, don't worry. We'll have a very short break before we start the next session in like 15 minutes, maybe a bit less. Yeah.
All right. I hope everyone is enjoying the summit so far. And I want to say a huge thank you to Bright Security once again for helping us out with this event, for joining us, and for sponsoring this event. And just to tell a couple words about their really cool product and the developer first scanning tool. So this application security testing scanner enables developers to integrate security testing across all your development pipelines with no false positives, and to test your applications and APIs, SOAPs, REST, GraphQL on every build, basically. This industry-first Bright's new security tester integrates with JavaScript unit testing, and you can test components and functions for security bugs in literally seconds, maybe like minutes maximum. And what's really cool, we have the free accounts for you. So we have the link for the free accounts. You can register and start scanning today. And if you want more hands-on, in-depth coverage on how to use it, how to set it up, we're going to have a hands-on workshop on Wednesday, 12th of October. The link for trial version and also for the workshop are in the chat. So you can use those to register and to grab yourself basically free access to security testing. And yeah, be sure to check out Akira's talk today. And if you've missed it, you can watch it in recordings after the summit. Thank you once again, Bright, for helping us and for sponsoring this event.
Hello, attendees of the Geekle Global JavaScript Summit. My name is Akira, and I work for Bright Security. At Bright, we build something called a dynamic application security testing tool. What this tool does is it scans your app from the outside in, mimicking the way a hacker would interact with your app to see if we can find security vulnerabilities. But don't worry, if and when we do, we don't take down your app's production. One thing that is really cool about us too is that we have a new feature called SecTester. SecTester allows you to take our Dast engine and integrate it with your unit tests. So not only can you do regular unit testing now, you can actually add security testing at the unit testing level. This is earliest in the software development lifecycle that anyone has ever been able to integrate a Dast tool, and we are super excited about it. I'm going to give a workshop on October 12th to show how to configure this, how to use it on a vulnerable web application that is one of ours, and so that you can go back and use it in your work, use it in your side projects, use it however you choose. Again, the workshop is October 12th. It's at 8 a.m. Pacific, noon Eastern. You can register for it by going to brightsec.com. That's BRIGHTSEC.com, or you can click on the link in the description below. Thanks so much for your time. I'm really hoping you come to this workshop, and we will see you soon. Bye.
Hello, everyone. My name is Marian Villa. I'm from Node Tours, and today I'm here happy to introduce Deepa Subramanian. I'm going to talk a little bit about this amazing speaker. So Deepa Subramanian has over a decade of experience as a software test professional. She enjoys building front-end and full-stack web applications. She is also passionate and curious to learn about new technologies. She has a background in food science. She is an Adobe an organizer for Google Developer Group San Jose, and an ambassador at Google Women Tech Makers. Today, she is going to share with us building UI components using Storybook.js. And for those ones who want to know more, Storybook is an open source tool for developing UI components in isolation for React, Vue, or Angular applications. So Storybook.js makes building organized and efficient UI. Developing reusable UI components and is not easy as you may think when you work in large teams. So in this talk, she is going to show us how to use Storybook with React applications, and she's going to bring a use case to this stage. So please welcome.
Everyone, thank you so much, Geekle, for having me here. Today, we'll talk about building UI components using Storybook.js. My name is Deepa. I'm a QA developer at Adobe. I also enjoy building front-end and full-stack applications. I'm a part of Google Developer Group as an organizer. I'm also an ambassador at Women Tech Makers. I do write blogs. And here the base that you can connect with me is through LinkedIn, and every slide on the top right would have my Twitter handle. And fun fact about me is I'm an avid coffee drinker. So today I assume that you have the following knowledge already. So you should have familiarity with HTML and CSS. You should know JavaScript, ES6, features, arguments, parameters, etc. And you have worked already with a React application. You know how to create a React application, what is a component, what is JSX, fragments, etc. So the agenda for today is we'll start off with something called as component-driven development. And then we'll deep dive into Storybook. Where does it fit inside component-driven development? What is it? Why you need to use Storybook? And what are the companies that use Storybook? And we'll see how to write stories. We can add controls to our stories using arguments, parameters, decorators, etc. And we'll also talk about how to add, how to install an add-on. By default, Storybook comes with add-ons, but we can also see one of the add-ons and see how an installable add-on works. Finally, we'll wrap it up with a Q&A. So just to give you a visual, this is an evolving front-end development graph that I picked up from online. As you can see, this graph starts off at 1995 and it goes till 2019, which is not too recent, but at the same time, a lot of things are holds true even today. So if you see in the JavaScript ecosystem at the bottom, there's a lot going on from the past decade or so. Angular started coming up in AngularJS started coming up in 2011-ish, and then you have React, then React Native came up, Vue, and now in 2015 or so, Angular came, and then there's also changes to the ECMAScript if you see. So there's a lot more that's going on in front-end development. So this is making this evolving front-end is very tricky these days to build UI, right? So what do we have now? So what are the ways that we could make our lives easier? So there's something called as component-driven development. Tom Coleman introduced this in 2017. He describes the shift in UI development towards component architectures and processes. So the idea of modular UI has many parallels when you see in software moments such as microservices and containerization. What Tom says is that you need to build UI from bottoms up, right? So you start building from bottom, and then you ended up at a page or a screen level, right? So here are the steps. You start building one component at a time, one piece of component. For example, you add an input or a button. Then you combine it combine those components inside of a form, right? And then when you assemble them inside, and assemble the form inside a page, for example, a sign up page, right? So then where you can mark it with the data. And finally, you integrate your pages along with the backend services and APIs. So this is one of the architecture that you have. There's other architecture like micro frontends too. So what is Storybook? Storybook is a development environment and a playground for creating UI components in isolation. Right? It's a sandbox environment. It runs outside of your React application or Angular, whatever framework or a library that you pick up. So it does not need any business logic, and you don't need any APIs or data to make this work. You just focus on component level development here. So why in isolation? Because we are focusing at a component level and not thinking of a page level, it becomes easier for you to create these components. And you also ensure the quality of your software that you're building improves due to this isolation. And when you're working in large teams, the communication between teams becomes easier. We'll see that in a moment. So why Storybook? Like I said, we are building this in isolation. Imagine a React application looking like this, right? You have so many components. Think of Instagram, Facebook, Airbnb. They have so many UI components. And think of how do we create these things, create these UI components. How do we interact? How do we see how the interaction goes? And how do we test them, right? Whether they look and feel in different ways. And as I'll be showing you how Storybook looks in the playground and how you can see the environment as such. So Storybook makes it super easy and super simple when you're building components in isolation. So Storybook supports TypeScript and JavaScript. So Angular users can use them. And it also supports other frameworks too. Because you're creating this in isolation, if you want to see how your whole UI renders, you can also check the performance using their add-ons. So Storybook also has an add-on for accessibility, where you can make sure that your components are accessible so that when you integrate them as pages, your page becomes accessible too. So it's a very neat tool. I'll show you an example of how to install accessibility and a small snippet of how, when you run this installed add-on, how accessibility looks like, right? And you can also test your UI using Jest and Playwright. Now, how do you install it? So first, you need to have your React or your Angular app. Remember that Storybook works only outside of your application, but you need to have your application there for Storybook to work. So then you install Storybook. By default, it installs in Yarn. If you want to use Node, you can use this flag. And if you want to run your Storybook on localhost, you run this command. And Storybook has just released with their version 7. Sometimes it might throw some error. Make sure that you upgrade Storybook, and then it should be good to go. Now let's see, how the project folder looks inside of Storybook. This is the project folder after I installed Storybook. Here, as you can see in the left, let me just, this is my React app called My App. And as you have two folders, .storybook and stories inside of source folder. And if I go ahead and click on the .storybook, there are two files, main.js and preview.js. Now let's go take a look at main.js. Main.js is an entry point for Storybook. So basically it looks for all the files that contains .stories as an extension. And as you can see, it says .stories, it can be a JavaScript file or a TypeScript file. And also when you install Storybook, it has a add-on that comes up with this. So this is where if you want to install something in Storybook, if you want to add on an installation, this is where it will show up. So in preview.js, this is mainly for both these files are for configuration purposes only. So preview.js is a configuration file for global. If you want to assign something globally to a story. For example, I want to add I'll be showing you an example of how do you add a background to a button, right? You can do that using the preview.js. And you can also, if you want to customize all your components in an alphabetical order, and you want to make sure it is in some kind of an order, you can sort them using mentioning all those things inside of preview.js. So whenever you make changes to either main.js or preview.js, you need to restart or rerun Storybook again. And now let's go take a look at the source folder where I have stories. And as you can see, there are three folders for three files for buttons. One is for styling. One contains a React code, and then we also have stories for this button here. So if you see this, there's button. There is a button component, a header component. There is something called as introduction.stories.ndx, which is nothing but a document file. I'll show you how it looks like in the Storybook playground. And there's also a component for page. So now let's go ahead and take a look at how it looks in the local host, right? Here's the introduction.mdx file. If you see here, there are a couple of, it usually shows up in the canvas. And this is just, it is very similar to how do you write a README documentation, right? Very similar to it. There is also ways that you can add code snippets into this. And there are documentation for this in Storybook, if you can go ahead and take a look. And this is very similar to the project structure we saw, right? There's a button component, there is a header component, and there is a page component. And inside the button component, you see there are 4 stories. So a component contains of many stories. Here, each and every story is laid out separately. And if you see, there are controls here. Just to mention that this part of Storybook is the toolbar. And the whole thing, this is a toolbar where you can see the background that you can set it up. There is also a viewport here, whether you can set it up for a small or large or a tablet size, and you can reset it as well. So this is the toolbar. So down below here is the control panel where you have controls, actions, and interaction. By default, these add-ons comes with Storybook when you install them. Here, we know in this primary button here, there are a lot of controls. So for example, if I go ahead and toggle this, so I can set this to set this button as not a primary one. And I can also go ahead and change the label of it to say my button, right? And instantly it changes. So if I want to choose a different color for this button background, I can go ahead and do so as well. So here you go. The button color has also changed instantly. And I can also go ahead and pick the sizing for this button. I can do small, medium. By default, it was a medium. Now I can go ahead and do it enlarged as well. So this is how you can add controls. Make sure that when I made changes to this story, the secondary button did not have any changes. So you can customize your controls for each and every story. And now let's go ahead and see what is inside the header. So here I have Jane Doe as a text. So let's go ahead and change this to Geekle. So it's a string, so I need to make sure it's in quotes. Once I do this, so it reflects on the top right? And also see that these are required field, this login and logout. If I click on logout, watch out on the actions tab here. So if I do that, there's an action event that fires up. It gives you what is this event all about and what did we do? Here we made a click event. So that's on, if I go ahead and do the same thing with sign up, it's going to show up the actions as well here. So now let's move on to page. This page story would have, here we don't have any controls to it, but I just wanted to show how interactions work with page. If I go ahead and say it's logged in, now if I go ahead and see in the logged in, it shows the interaction. Just because I said login, it fired up this interaction too. So this is how Storybook looks, this playground looks. And as you can see, it's very easy to navigate through this and look into the UI. And also I wanted to show something here in package.json. See, Storybook is installed as a dev dependency. Here you can see there are some essential add-ons, interactions, links, and you would see the same thing in main.js too. So this is how Storybook looks when you install them. And we'll also talk about how to add your own controls, and we'll see from there. So now, what are the different types of components we can have in Storybook, right? We saw default, there were default components, but you can also create other components such as footer or inputs or table or anything, or an action bar. So for example, we at Adobe use Storybook for creating all our components. So here is this is an open source project. You can go ahead and take a look at this. And just to give you, I just took a partial screenshot of what are the components that we have it in Storybook. So as you can see, there are badges, banners, button groups, cards, dividers, dialogues, and there are a lot more. So you can create as many components as possible, and this way you can share it across your teams. Adobe has different products, but our UI has to look very similar across different products as well. So we use Storybook for this purpose. And we talked about this. This is how Storybook works. Storybook looks in the playground. The essential add-ons are your toolbar and your panel, which contains control, actions, and interactions. And also you have we talked about documents that you can create. This comes as an essential add-on inside where you can see it inside of package.json and in main.js as well. So this is what we saw. So what does these add-ons do? This add-ons gives you all these things. You can set up backgrounds, right? So now moving on to what is a story, right? A story is a function that describes how to render a component. So it describes all the state inside a story. So let's see how to write a story for a button in a moment. So here's an example for button story. And if you see here, there are two exports. One is a default export. The other one is a named export, right? So in the default export, you have properties such as title, and the title is mandatory, and it must be unique. So this is what you will see it in the side panel of the playground in Storybook. When I say forms.button, forms is a component, and inside the forms, there is a button story. So this is how it is organized, and you can have as many, like how I showed it in Adobe's component stuff. You can have as many as you want, but make sure that these are unique, right? And there is a named export. These are React components, and they represent individual stories. For example, here I have a submit button, next button, and the OK button, cancel button. Each one of these are individual stories. And as you can see, there are different variations too. Just give me a moment to show the screenshot of this. See, this is what we have created using this. And as you can see, there are in different colors, but there's no controls added because this is a custom button that I've created. There's no controls. So how do we add controls? You can add controls using the following ways, but there are a lot more, many other features, but I'm going to be mentioning only these three today. We can add controls using parameters, arguments, and decorators. So here's an example for how do you add a parameter for controlling your component, right? Parameters basically are methods that defines static metadata for your stories, right? It provides configuration to various add-on. Here is an example of how do you create a background for a button for a button component. So for example, I have cyan, blue color, green color, and red color, right? So let's see how it looks in action in Storybook Playground.
So the background is now in red. So if I go ahead and change this to cyan, I can do that, and all the stories will have the background of cyan. And if I want to change it, I can go change it to blue or any other color that I want to have. So this is how you would define or you would add parameters to your stories.
We saw an example of parameters. Now let's see how we can add arguments to your stories. So you can add arguments at a story level or at a component level. Arguments are nothing but objects. In a JavaScript, objects are nothing but key value pairs. And as you can see, I have added, this is an example for adding an argument for a success button. So I have used Material UI code here. So what it does is it'll show you can only use certain key value pairs that is mentioned along with Material UI too. So if you're using any design system, make sure that you follow their documentation, and based on that, you can assign key value pair. I'll just show you, and also note that we are using template.bind, which is nothing but a JavaScript technique to make a copy of a function. So we copy the template so that you can, so that each exported story has its own property. We can export it to different buttons that we are creating too. So here's a demo for arguments.
Example for Material UI button that I have I have imported. For the success button, I have 3 arguments inside, and arguments are nothing but objects, and you can use it along with
template bind so that you can make a copy of it. This is a JavaScript technique to copy a function. So if I go ahead and see in the Storybook playground here, I can see those arguments here. I can go ahead and change this to, for example, I can go ahead and change this to OK, right? And I can also change the variant to, because we are using Material UI, we can only use certain values that Material UI has in their documentation. I can use this as outlined one. Outline, make sure that you don't make any typo, otherwise it will not work. I can make a click, and also I can say text. These are arguments that are supported by Material UI. So now it's a text, it shows it as a text. Now if I go back to say contained, it'll show as info. So also each of these can be changed for every single story. This is how you can define arguments. Now, moving on to decorators, right? So how do we use decorators inside our stories? So it's a simple way of wrapping one piece of code to another. Basically, you're decorating it. If you see on the code snippet here, we are adding a decorator for our success button, and we are making small tweaks for our styling. So we are basically adding a margin. We are adding a styling or decorating it, and saying that the margin has to be 3M. This is how you would add decorators to your stories.
Now let us see how to add decorators, right? For the same button, Material UI button, I'm adding decorators. Decorators are nothing but you add it for some decorative purposes. For example, here I have added a margin of 1M inside the success button and inside the error button too. So if I go ahead and change this thing to 15M, for example, now it looks like this here. If I go ahead and change this to 15M on both success and in the error button, if I go ahead and see, now as you can see, it has moved away. See, the margin has moved. So this is how you would use arguments and decorators inside of Storybook.
So we saw how to create decorators, but there are different ways that you can create decorators. You can create one at a component level, a story level, or a global level. We saw one example. If we create something inside, like how I showed you before, we can add a component decorator using those decorators inside of default export, right? So here is a way you can define your component decorator inside of your default export. So if I do this, I've added a margin. It shows up for all the buttons here. It has added those margins. And then finally, it says, okay, your margin is added, right? You basically add the styling inside of a default export. So for a story decorator, you need to do the same thing inside a named export. If you use it along with a bind method and you're creating for a specific story, then it comes under, you write the same code inside a named export. So now, what is a global decorator? Global decorators are decorators for all stories that you want to have via a decorators export inside of preview.js. If you remember, there's a .storybook folder, and inside that preview.js is there. And if you want to add a global decorator, this is where you would do it. So far, we saw what are the add-ons that came up with Storybook. And I also mentioned that we can install add-ons, right? You can install add-ons like for accessibility, performance, and for test. Here, I'll give you an example for adding an accessibility add-on. Once I go ahead and run in Storybook, you have to look for that add-on inside the Storybook documentation. There is a command for adding the accessibility one. And once I add that, it'll show up in your main.js file. So here, once I add that, it'll show up in all my stories. It'll add if you see in the panel, it added accessibility. And this accessibility is available to all through your stories. It can be for the button component, it can be for the message, and all the components that you've created. And it also gives you certain indexes. So for example, although this button has passed, there is no violation and it passes, but it also tells you, hey, you could improve this or make it more accessible by fixing these things, right? It gives you certain levels of accessibility, such as, oh, this is a critical accessibility issue that you might want to address. And there are serious ones and there are warning ones. Warning ones are generally not, you have to basically pick up the critical and serious one. And if you click on the more info link on the panel, it would take you to DQ University. It is a organization that basically lays out how your accessibility should be for a website. So they'll give you code snippets as how do you improve, and you can take a look at that. And based on that, you can make your components accessible. When you make components accessible, finally, you make your pages accessible as well. So now we've talked a lot about Storybook. Let's see wrap it up with some of its benefits. As I said, you are developing these things in isolation, so it's more durable, and you can test, each of your components separately, and then because of that, there's less effort and there's no flakiness. And there's also a possibility that you can create documentation and you can share it across teams and they can all reuse it. So basically you write once and then you can reuse everywhere. Like I said, you can share, and overall it improves your code quality. So what are the companies that use a Storybook, right? At Adobe, we use Storybook, and Microsoft uses this. And there are so many companies. There are over 30,000 applications that use Storybook for their development work. If you go to Storybook page and look for Showcase, there's a lot of companies that are listed there, and different components that you can take a look at. Probably you can start customizing it for your own needs. So here is an example that I added for how as a whole Storybook would look like.
It's an example of an application, which is nothing but a virtual or a hypothetical coffee store. So I've created, this example, I picked it up from GitHub. So it has a item card, there's a card one, and there's button with a default one, and then there's footer, there's a cart, and header has something called as some awesome coffee, and this is a text, and also there's a cart, checkout cart. And once you run the whole thing in a local host, the page looks something like this. So this is a coffee shop where you have all these products where I can go ahead and search for cappuccino. If I go, and it's unfortunate that the cappuccinos have pizzas instead. So if I go ahead and clear this, and it just picks up random images from Unsplash. So here is a code snippet of all the, here is where I am trying to run this thing. So this is a coffee shop example. This is an item one, and there's a story here for the heading, and then there's also there's an API for, basically it's a mock data that's coming for all the images, and it's coming up from this. So this is how you can use Storybook, and you can put all the components together and make it work for your web application. I hope this demo helped you to understand how Storybook can be useful.
So to summarize, we talked a lot about Storybook. Why do we have to build components in isolation? What are its benefits? How you can create stories at a component level, at a story level, and as a global level as well. There is a lot more to this. This is just a very small, quick demo of how Storybook you can start using Storybook for your projects, right? And we also talked about add-ons, showed you how to use accessibility here. So with this knowledge, you can take it to the next level. You can start you can see how you can integrate it with an API or write the same thing in Angular with TypeScript, right? And you can also see how you can test it. So the possibilities are a lot if you want to explore this particular tool. So once again, my name is Deepa. You can connect with me in LinkedIn, and you can also check out our events at GDG San Jose. And here are my references. Please let me know if you have any questions. Thank you so much for giving me this opportunity.
Thank you, Deepa, for your awesome presentation. I really want a cappuccino, and it was really clear how to use building UI component using Storybook.js. So thank you for your time and for this amazing content. We're ready for another awesome presentation. So I'm going to invite right now Rameez. So hi, Rameez, how are you?
Hello, I'm doing good. How are you guys doing?
Good, good. First, I'm pronouncing well your name.
Yeah, it's Rameez.
Rameez. Okay, that's why I want to check. So thank you so much for being here with us. I'm going to introduce you right now. And if you want to add something, so please go ahead at the end of this short presentation. So Rameez is a software engineer with 8 years of experience in full stack web technologies with expertise in front-end development. He holds a master's degree in computer science and developed with small and large agile teams, created custom-driven and Fortune 500 business-driven solutions. And today, he is going to share with us web components and their applications. In the abstract of this talk, he talked about some teams like to use React, some like to use Vue, some just go with vanilla JavaScript, and some like to use Angular. So oftentimes in this kind of a scenario, it is really hard to reuse code from other teams and to provide consistent user experience. Learn how web components can help in providing consistent UI UX in all products and in promoting reusability of code. So this sounds amazing. So do you want to add to this presentation?
Yeah, I just want to add a few things. One thing that I like to flex about is I work for AWS in the CloudFormation team. And one thing that I love doing is interacting with new people in the industry, new software developer, or if you are someone who is not in software development and who wants to join software development, then I would love to have a conversation, because I believe like once you are in the industry for 1 or 2 years, you kind of learn how to self-learn. Like you have a lot of stuff available online, so you can just go ahead and learn it. But when you are new, then the real learning curve is there. Like when you are brand new in the industry and you have so many things in front of you, you don't know what to learn and what to not learn, where you should spend your time. So that's what I like talking to the new people, and that's why I'm here, because it is for the junior, it's in the junior track. So that's why I'm here to have a discussion with the junior software engineer or future software engineers. Yeah.
Thank you so much for paid back to the community. I think it's all about community and helping others to be part of the industry. So thank you for this amazing talk. So right now, thank you again for your introduction and for your time. And we're ready to hear you right now. So I'm going to add to the stream the presentation. Thank you, Rameez. The stage is yours.
Awesome. All right. So today we are going to talk about web components. And before that, the way I like to present is, so my end goal, first of all, let me just move it to the full screen. And yeah, I hope it's clear and it's visible. I'm perfectly audible. If not, then let me know. So anyway, the way I like to present work is I want to make sure that everything is super clear. I don't like to use difficult words or any fancy vocabulary. I just want to, strictly to the point and make sure that everyone understands or everyone gets something out of this presentation. If you know nothing about software development, I hope you're going to learn at least something from it. If you know a little bit, I'm sure you will know about web components after this presentation. So yeah, let's get started. So today we are going to talk about, or we are going to answer these 5 questions that we have. So this is the you can say agenda for today. We will learn like what are web components first of all, and then we will talk about like what are the fundamentals we need to know in order to use web components. And then number 3, we will talk about like what we can do, what we can achieve with web components, or what are the applications of web component in the real industry. So yeah, and number 4 is everything has trade-off. So web component also have trade-offs. So we're going to learn about like what are the things what are the limitations that you need to know before writing your application in web component. And then number 5, we will look into the demo that I've made. All right. So number 1, let's jump into the the definition for web components. So in the simplest word possible, web components are used to create custom HTML element or extend the existing HTML element to accommodate your custom functionality. What does it mean? It means that, let's say, if you have ever used HTML, you must know there is a tag called input, like you use this kind of thing, right? So this is a default. This is available by default in the browser. It's going to work in any browser. It's just available, right? So what you can do, you can define these kind of components. Let's say you can define my custom component and add any functionality to it, and it's going to work. So, but again, what's so new about it? You can also do the same using React or Angular. The uniqueness of web component is in the next part. Like web components API are part of the default web platform API, and it follows existing web standard. That means web components work in the modern browser without needing any third party. So that's the real value of web component, that it's gonna just work in the browser without needing anything at all. Like if you want to use React today, you cannot use React just in the browser. You have to have npm install for the React, probably React DOM as well. Probably you have to have Babel configured. You have to have Webpack, right? All these things. But when it comes to web component, you don't need anything of that. Like you just get started. Like all you need is JavaScript, HTML, and CSS. That's it. And you can write your code in it. You don't need to even have any package.json file, anything. So your code is going to be super lean. So that's the real value. And yeah, we're going to discuss it later in detail. Now let's jump to the next part. And also, if you have any questions, just keep in mind, or if you know about it already, if you have learned about web component before, so try to find if I'm missing something, or if I say something that is not correct, or if I'm saying something that you don't agree with. So you can keep that in mind, and we can discuss it later. So yeah, let's move on to the next part. That are the fundamentals of web component that you need to know before start writing your code. So first thing first is custom element API. So that's the API that's available in the browser that's going to help you in writing your web component. So basically, set of native JavaScript APIs. By native, I mean that they work directly in the browser. You don't need anything in the middle to make them work. And that allows developer to define custom HTML element or extend the existing ones. So here is some code snippet that we can look into. So let's say if you want to define a web component. So what you're going to do first of all, you need a class. Again, in latest JavaScript or in ECMAScript, you can define a class. And then you have to extend it with the HTML element. That again, everything is provided in the browser. Your browser exactly know what you're doing. You don't need to add any third-party library. And then there are some like bunch of hooks that are available in this class, or bunch of, you can say, lifecycle events. We're gonna talk about them later. So that's how let's say if you are creating your web component, that's the first step. Like you're going to create a class of your web component, extend it from the HTML element, and then inside it, you want to encapsulate the functionality that you want to put. Let's say what do you want to render with this web component? Let's say if you're rendering a button, then what's going to happen if somebody clicks a button, or what's the CSS for that web component? Everything you're going to define within the scope of this class. And then now you have to, once that is done, now you have to register that web component to the HTML. Like you have to tell the browser that this is my component and this is what I want to call it. So here I am registering this class, my custom element, and I'm saying that I'm going to use this tag, my custom element. So what I'm saying basically that whenever I want to use it, I will use it like this, my custom element. That's the way to register it. So that's it. These are the like two things that you need to define your web component. And now let's talk about the methods that are there. So like every other class, let's say we define class in Java, so it needs to have a constructor. Like when you create an object, it has to have a constructor to tell like what do you want to what are the initial values that you want to define. That's going to go in the constructor. This constructor get invoked when element is created either by document.createElement. So if you know about DOM, you know that we can create HTML element using this API that is available in every browser. That is document.createElement. Like there are a lot of methods available. One of them is createElement. So you can create a new element using this, or you can just write an HTML file and then just put my custom element. So this constructor is going to trigger. The first thing that's going to trigger in this file is going to be this constructor. And then there is another lifecycle event that is connected callback. That is like if I find an alternate in React, that's like component will mount or component did mount, something like that. So yeah, similar to that. So it's going to get invoked when the custom element is first connected to the document's DOM. Like whenever this element gets connected to the DOM, that's when this is going to get called. And how you can connect it to the DOM? By using this method. There is, again, in the DOM API, like we have create element method, similarly, we have an append method. Like you can append a child to the existing DOM. So whenever you call it and then pass this component as a parameter to this method, it's going to invoke connected callback. Or you can also dynamically add this in the HTML, let's say based on some flag, show my custom element. So whenever that is true, you can render it. So every time this will get called. So the difference between constructor and connected callback is just the number of times. Like the first one, constructor is only going to get called the first time. Then it's not going to get called again. Or it's going to get called whenever you are initiating this web component. But connected callback is going to get called every time it's going to get appended to the document. So yeah. And then number second is disconnected callback. Again, it's quite intuitive, is the complete opposite of connected callback. It's going to get called whenever you're going to remove this from the DOM. So, okay, yeah. So for the connected callback is used to make API calls. Let's say you want to fetch some data, you're going to put it in the connected callback. Or whatever you want to do whatever you want to do whenever this web component gets rendered. Like there is some functionality that you want to attach. Let's say you want to fetch some data or you want to refresh data whenever it gets rendered, you should put it in connected callback. Or let's say you want to bind the event listeners. Let's say you have a button in your component and you want to bind a listener to that button. That's something that you're going to put in connected callback. And in the disconnected callback, you're going to deregister that button. Like you're going to remove all the listeners to the event, unbind them so that they will not get triggered once the component is off, or so the memory is free. So yeah, the third one is adopted callback. You're not going to use it in normal scenarios. It's only useful when you have iframes in your application. So when you're going to move, so there is a way to move. So iframe has their own DOM separated from the main DOM of your HTML page. So when you going to move, and there is a way to move a node from one DOM to another DOM. there is a method called document.adopt node, something like that. So whenever you're going to do that, whenever you're going to move this component to another DOM, adopted callback is going to trigger. And again, it's similar to connected callback in that sense. Like it will be the first thing that will get triggered, and you can run the API calls or whatever you want to do whenever you move a node from main DOM to the iframe. And yeah, the other one is, the next one is attribute changed callback. So if you know about attribute, so in HTML, there is a thing called attribute. Let's say you have input, or let's say take something else. Let's say you have div and you have call span. That's an attribute. You can define a value here, whatever, like 2, 3, 4, 5, whatever. So it's just a arbitrary value that you put in your. It's a way to pass data inside your component. So if you want to do something whenever an attribute value is changed, you have to override this callback. You have to put, let's say I want to log, let's say this is my custom element and I have an attribute called value. And what I want to do is whenever the value gets changed, I want to log it. So what I'm going to do, I will override this callback and just put console.log this.get attribute, something like that. And then here I will put value, something like that. This is what I'm going to do inside attribute callback change. But at the same time, you don't want it to trigger for all the attributes. Some attributes are not. Some attributes are just the first time. Like you just want their value the first time, and then you don't want to track that value. So if that's the case, so for the attributes that you want to track, you have to return it. You have to return the list of them in this method, like observed attributes. So we have another method. So whatever you're going to return, you have to return a list of attribute from this method. So that list will get tracked. Like whatever is included in that list, our web component is going to track the value for that. And whenever any of them gets changed, attribute changed callback will get triggered. So yeah, these are the lifecycle events. And again, let's go back to, yeah. So yeah, we already discussed, like this is the way I'm telling the HTML, like how I'm going to call my web component. And again, we already discussed lifecycle events. And there is, yeah, this custom element can be used like a normal HTML element, like following. I already talked about it. And then we can also, so this is one way. And another way is, let's say you don't want to define your own tag. Let's say you want to use the existing HTML tag and just override the functionality of it. So then you can also then this is the way to do it. Like here, it's just exactly same, but the difference is that now I'm not going to call my custom element in HTML. I will rather do something like this. I will do div, and then there is an attribute called is, and then I will say my custom element. The benefit is that I'm getting all the, so div has some properties, right? Like div has a specific kind of a styling to it, or let's say paragraph has a specific kind of a styling to it. So I can reuse that in my custom element. Like I don't have to implement that. I can just extend it, like the way inheritance work in Java. Like you don't have to, you have a class, you want to define another class that has exact same functionality as the class A, but just some more functionality on top of it. So you're just going to extend it. So similarly here we are extending the functionality of div and just defining our own custom functionality on top of it, or overriding it, whatever you want to do. And then, yeah, so now we can use div as following, as I talk about it. So yeah, this is done. Like there are other, like if you want to dive deep, there are other methods also available in custom element. You can do it by yourself. But this is basically the methods of custom element API that you want to know before starting web component. Now the next fundamental concept and very important to web component is called shadow DOM. So I'm hoping that you guys are aware of DOM. If you are not, then you can. Its full form is Document Object Model, and you can say it's so when you see, let's say the page you are seeing right now, it's a medium HTML page. So this page has a representation in JavaScript, in terms of object. Why? So that you can play around with this page. You can add elements to this page. You can manipulate this page. So this page has a one-to-one mapping in JavaScript, and that mapping is basically called DOM. And JavaScript provides an API to manipulate DOM. Like you can add nodes to it, you can remove nodes to it, and that's how it works. Like that. That's how when you click on a button, it shows something. It shows a new div, and it hides existing things, something like that. So yeah, so the DOM is. But there is another kind of DOM that is called shadow DOM. So as the name suggests, it is different from your main DOM. It is not the part of your main DOM. It's sort of like a shadow of it. So what is shadow DOM? Shadow DOM is independent DOM tree that renders separately from the main DOM. It has its own rendering cycle, completely independent of main DOM. Nothing to do with it. Like it just live independently. Shadow DOM can be attached to any node in the main DOM. Shadow DOM allows custom element to be scripted and styled separately without the fear of collision with the main DOM. So this is the main point of having a shadow DOM. Like you don't want your custom functionality to leak outside of your custom element. You need a way to encapsulate that within the DOM. So if you know about CSS, let's say here is the screenshot. So here I am on the left. That's how it's going to look in the browser. That's how it's going to render. And on the right, this is the HTML structure that we have. So if you know about CSS, there is one thing that if you define style like this, let's say the first line div, background color, light blue, you know that now every div will have the background color as light blue, because that's what. But here inside the shadow DOM, I'm also defining the same. I'm also using the same style, just changing the background color to something else and adding other styles. So here, this styling is only restricted within this red box. It's not leaking outside of it. Why? Because it's a shadow DOM. If you do it without shadow DOM, this style is going to make every div with the background green, with the background color as green, because it's a normal. That's how it works in normal DOM. Like whenever you put a style like this, like div, and then it's gonna get applied to all of your divs. But since I'm defining it inside the shadow DOM, that's why it's only staying within shadow DOM, and you cannot change it from outside. Let's say this hello world has a green background color. Why? Because the style is defined within it. It's not getting the style from it's not getting the CSS from the style tag that is defined outside of shadow DOM, the first one. It's not, because its color is not light blue. So it's not getting. Why? Because this world is isolated inside the shadow DOM. So power of shadow DOM, that you can isolate your functionality and keep it within the shadow DOM, and it cannot get affected from outside. Neither it can leak outside. So yeah. And as you can see, the div outside of our web component message. So in this case, the web component name is message component, and then this is the shadow DOM inside the red box. So if you define a div outside of it, that's actually getting this. It has a color is light blue. It's not getting this one because it has nothing to do with it. It's alternate. It's completely hidden from it. And yeah, so shadow DOM contains everything inside the red square. CSS defined inside shadow DOM is not affecting the normal div outside. Similarly, CSS defined in the main DOM is not affecting the div inside shadow DOM, as we discussed. There is one thing to notice, that shadow root open, this thing. It shows the shadow DOM, like this means that this is the start of shadow DOM, and this whole thing is part of shadow DOM. And it shows the shadow DOM was created in open mode. So this open thing means that it's created in open mode. There are two kinds of mode when you're creating shadow DOM. It can be open mode or it can be closed mode. So open mode makes the shadow DOM accessible from outside using DOM JavaScript API like following. So it's not accessible by default. It's not accessible in the HTML. If you want to access it, the only way to do it is through JavaScript. Like you can do something like this. You can do document.getElement by tag name. That is our message component, and then you can do .shadow root. So now it is returning you this. So now you can manipulate with it if you want. Why? Because it was created in open mode. But you can also restrict that if you want. You can create your shadow DOM. If shadow DOM was created in closed mode, the shadow DOM is only from the inside of custom component, and the above command will return null. So now if you create the same element and you just make it with shadow root close, then you cannot access it even with JavaScript. So yeah, that's the main difference. We will go through when I'm going to show you the demo. I'll also show you the code. So we will have plenty of example for that. So yeah, we can discuss it in the detail then. Okay, now the third concept that we need to know, that is HTML templates. So it's a again default HTML tag that's called template. It can be used for reusing the same HTML structure. Let's say if you have different kinds of form in your web application, like one form is left aligned, one form is center aligned, one form is right aligned. But so one way to do it is rewrite the HTML every time for every, or another way is that you will just define your form within HTML template with all the fields that are required, and just change the alignment in your components. So you can reuse the HTML structure. So how are you going to do it? By using template tag. And there's one more tag called slot. So slot is used for interpolating the template. What do I mean by that? Let's say in JavaScript, you can have a string. Let's say you want to you have a string. Let's say something like this. You have a string hello, and now here you want to put a dynamic value. So that's how you interpolate in JavaScript. Same thing, same concept in HTML if we use slot. So slot is like wherever you put slot, that means you want to use a dynamic value that's going to be passed from the parent. As for whatever you're going to pass as a child component, it's going to be rendered inside slot. So yeah, and slot can be used for interpolating dynamic data in HTML. That is, it will render the value passed as a child to the web component, or the default value if no child is passed. So you can also define the default value. If you're not passing any child, it's just going to render that default value. So we can define template anywhere in the HTML file. It needs to have a unique ID so that we can get the template using get element by ID. So of course it needs to have a name or ID. You're going to use that to get it in the JavaScript file and attach it to your custom element. Without that, you cannot do it, or you need a class, some way to uniquely identify this template. So template can encapsulate any HTML structure, including style type. So this is the way to define a template. Like here I am using template tag with ID hello message template, defining an HTML, defining a style inside it, and then also using a slot. So here what I'm saying basically that by default I want to render hello and then world by default. But if you pass some value as a child to the web component, then that child is going to render here instead of world. So this is what I'm saying. I will show you. So yeah, template can be attached to the web component like following. So let's say if you want to use this template in your web component, what you're going to do, this is where you are defining in your constructor of the web component. You will first of all, you're going to extract it from the HTML using this get element by ID, hello message template, and then content. And then you're just going to attach it. You're just going to append child and then template clone node true. So what you're doing is just creating a node using that template and this appending to the shadow DOM of your web component. And this is how it's going to look in the browser. So it will render hello world if no child value is passed to the hello message component. So here, if you can see, we have a hello message component and no child is passed to it. This is not a child. This is a shadow DOM inside it. No child is passed to it. That's why it is rendering the default value that was world. So in this case, it's rendering default value that is world and also making it italic. Why? Because we have defined the style, font style to be italic. So it's putting that. We have defined the name slot class and put the font style to italic to it. So slot has that class name slot. That's why it is italic. Or it will render any value that is passed as a child to the hello message component. So in this case, as you can see, hello message component has a child, Rameez. This is a text that I'm passing. So in this case, it's ignoring the default value that is hello and rendering what I'm passing. So yeah, that's the power of slot, that you can use them to render the dynamic value. So now the same component can be used to render to say hello to multiple people, to n number of people. You can use the same component to say hello to any number of people. All you need to do is pass their name as a parameter or as a child to this web component. All right, so this is sort of the fundamentals that you should be aware of. There are a lot of other things, other details that you need to know in order to be an expert. But this is something that I think good to know before starting. Now we're going to talk about like what are the real world application? Like what's the value of web component? Like we can do everything that I have discussed so far using React or using JavaScript or using Angular, using Vue. So why do we need web component in the first place? So the first and the most valuable attribute of web component is gonna make your organization free of framework. Like you have no dependency on framework. If you write your code in web component, that means it's going to work with any framework, because HTML is all it is using is HTML, JavaScript, and CSS. That is supported by all the browsers, all the modern browsers. So yeah, since web component just works natively in modern browser without needing any third-party library, this quality makes them compatible with any framework or library, because web components are just like any other HTML element. So web components are just like input element. Input element works with React. Input element works with Angular. Input element will work with any framework that's even going to come in the future. Otherwise, it's a pathetic framework if input element doesn't work in it. So yeah, this allows different team and organizations to be framework agnostic. Like you now. If you are writing your code in web component, is going to work. Now we don't have to worry about, we all should use React so that we can share our code. You don't have to worry about it, because you are writing your code, you are writing your common code, your mutual code in web components, and now it's consumable by any other team, no matter what framework they like to use or anything. Yeah. So meaning they can pick whatever framework or library they want to use and still have shared UI components written in web components. So for example, this is a like real life like example from like all the big organizations, let's say Amazon, Microsoft. They never restrict their teams to use one specific framework. They never do that, because that's micromanagement. You don't want to do that. You want to empower your team to pick whatever technology they want to use, or whatever technology they think is good for them. You never want to dictate that, every team should use React. That's never going to work. That's like a very toxic culture if any company is doing it. So it just stops innovation. Like you are not cutting edge anymore if you do that. So let's say it's a very possible scenario that you have different teams. One team is payment, one is shipping, one is auth, one is orders. And payment team, let's say, use Angular. They prefer to use Angular. Why? Because probably their engineers have more experience in Angular. Auth team prefers to use React. Shipping teams prefer to use Vue. Orders team prefer to use Ember for any reason. So now let's say, now how they're going to collaborate? I'm sure there must be a code that they all need. There must be a common code they all need. Of course, they all will have buttons. Of course, they all will need alert bar. Of course, they all will need icons. So one way of going forward is that every team will implement their own button. Every team will implement their own alert bar. Let's say auth team will implement their buttons using React. Angular team will implement their buttons using Angular. But the problem with that, first of all, it's not dry. Like you are repeating yourself again and again. You have 10 different implementation of the same thing. So this is really hard to maintain. You are not reusing the code. You are not getting value out of others' work. You are not collaborating effectively. So what they can do instead, that they can implement their common components, let's say button, alert bar, icons, model, everything that a web application needs in web components, and then reuse and then they're gonna, and all these web components is gonna work for them without doing anything. Like it's gonna work with Angular, it's gonna work with Vue, it's gonna work with React, it's gonna work with Ember by default, because it's just HTML, it's just simple JavaScript, CSS. So this will allow organizations or different teams to pick whatever technology they want, and at the same time share their code with each other, or at the same time have common repository that will have all the common components that they want to build. So yeah, this is the most, I would say, useful application of web component. Number two is consistent UI UX. So now let's say if we do that, then there is a possibility that shipping team will use the button but will override the CSS of it, will have their own CSS. So that means your product, so all these teams are working for the same product. Let's say Amazon has a payment page, Amazon has a shipping page, auth page, and orders page, but the UI is consistent. The button looks same on every page. So how we can enforce this kind of restriction? One way of doing it is you will do the manual QA. Like you're gonna like one person will check whenever you release something new. They check that everything looks good. The CSS is not messing up. Like buttons are rendering exactly same on every page. Or one way of doing it is you develop your button in a way that style cannot be overridden by external CSS. And how you going to do it? Using Shadow DOM, because Shadow DOM has this ability to lock the style within that component, and nothing can override it from outside unless you define your Shadow DOM in open mode and then use JavaScript to override it. But I don't think anyone will do it on purpose. So you cannot override the CSS accidentally. There is no way. So by using Shadow DOM, CSS can be logged inside the web component, meaning that CSS CSS defined inside Shadow DOM cannot be manipulated or overridden from the outside. That is application CSS. Let's say orders application CSS cannot override the button CSS. This will lead to consistent UI UX across the board. For example, if you want round button in all of your products, then you will just make a web component with round button CSS logged inside Shadow DOM. And that will restrict any team from overriding it purposely. So it's not like one team will have a square button, other team will have round button. It's not going to happen. So yeah, limit.
So Rameez, thank you so much for your time. The time is running out. So first of all, we want to thank you. I invite you to share like this amazing blog post of Medium in our social media. So first of all, thank you for your time and your amazing content, for sharing your knowledge, time, and invest time in this event. So at the end of Rameez, we're going to jump right now to a bright announcement. So let you see you in short. Thank you, Rameez. Bye.
Hi, everybody.
All right. I hope everyone is enjoying the summit so far. And I want to say a huge thank you to Bright Security once again for helping us out with this event, for joining us, and for sponsoring this event. And just to tell a couple words about their really cool product and the developer first scanning tool. So this application security testing scanner enables developers to integrate security testing across all your development pipelines with no false positives, and to test your applications and APIs, SOAPs, REST, GraphQL on every build, basically. And this industry-first Bright's new security tester integrates with JavaScript unit testing. And you can test components and functions for security bugs in literally seconds, maybe like minutes maximum. And what's really cool, we have the free accounts for you. So we have the link for the free accounts. You can register and start scanning today. And if you want more hands-on, in-depth coverage on how to use it, how to set it up, we're going to have a hands-on workshop on Wednesday, 12th of October. the link for trial version and also for the workshop are in the chat. So you can use those to register and to grab yourself basically free access to security testing. And yeah, be sure to check out Akira's talk today. And if you've missed it, you can watch it in recordings after the summit. Thank you once again, Bright, for helping us and for sponsoring this event.
So thank you for being connecting with us. We're ready for jump to the last talk of this track. So we are welcome to Griffin Solot-Kehl. I'm going to introduce him. Griffin is a software advocate with over 5 years of experience working from baby startups to large companies. He's a proud native of San Francisco with a passion for improving the developer experience at all angles, from documentation, onboarding, accessibility, and more. So this talk is going to center around demonstrating how he is able to build immersive 3D environments all in JavaScript. He will show us how to build an interactive world in Babylon.js and demo in real time. So real-time audio, live stream media, increased engagement and retentions of user and broadcast quality workflows with low latency. We are going to learn this with Griffin. And remember, we are going to have a QA session at the end of this talk with our three amazing speakers. Deepa Subramanian, she talked about building UI components using Storybook.js. Rameez, Aijaz, Webcomponents and their application. And this final talk, that the name is A Browser-Based Metaverse with Babylon.js. So please welcome the last talk of Babylon.js. Just give me 1 second, I'm here.
Griffin Solot-Kehl, and today I'm going to talk. Hi, everybody. My name is Griffin Solot-Kehl, and today I'm going to talk about how you can get started building your own browser-based metaverse with Babylon.js. To begin, I do want to talk a little bit about our agenda today, where I want to go over a few things, including what is Babylon.js in the first place, give you some examples of what people have already built, and then start kind of going over how to really start coding with it, where we can do a hello world, start building some 3D assets and concepts, animating characters, and starting using videos as texture, which can then be used for things like live streaming and using spatial audio with perception. Finally, we're going to wrap things up, and I'm going to give you some additional resources so you can continue learning and playing around with this platform in your own time. So without any further ado, let's talk about what is Babylon.js? Well, it's a JavaScript-based library that is being used for 3D graphics rendering all within your browser, and it's all built within HTML5 and WebGL. This is really, really useful for a lot of different applications, including cross-platform game development, but also has been seeing use in areas like education, the medical field, blockchain, data visualization, and a lot of very interesting areas that people have been working directly in. You can see an example of what it actually looks like in this image we see on the right. We have a lot of really cool examples of things that people have built all directly within Babylon, which you might actually recognize a few of these. So for example, you actually are seeing Minecraft in the top left. This is a project that was originally backed by Microsoft engineers, after all, but you also see things like Temple Run over in the third image. We see Space Invaders, but turned into a 3D world, which is really, really cool. And it's also being used in other areas, like on the bottom right, we have an art gallery, and then on the one right next to it on the left, you can see that people have been using it to visualize different maps of areas that they've been doing research directly on. So this isn't strictly a gaming avenue, though that's kind of the beauty of the metaverse as well, where the metaverse isn't only really for games, it's for interactions and being able to communicate with a lot of different people. Let's begin talking a little bit about the Hello World and how to get started with Babylon.js itself. So the first things we kind of want to do is set the scene for what Babylon.js is actually going to look like, where we all kind of wrap everything together inside of one main method that we call createScene. This is where we're going to be able to generate objects, which not only includes the typical objects you might think of with polygons and spheres and cubes and all the like, but also things like your cameras, your planes, your lights, and your meshes that are going to be the kind of building blocks of what's going to be able to create your scene in the first place. These are all called from functions like mesh builder, free camera, hemispheric light, as well as a bunch of other ones that are very cool. A very common way that we're going to be able to determine how these things all are placed relative to each other is by using vector-3 formats, which simplified down is essentially defining the XYZ coordinates of these objects, all relative to the scene, with 0, 0, 0, of course, being the origin of the graph. This does go properly into negatives and decimals, as you might expect. What's really cool about Babylon itself as well is that autocompletions are given directly in the npm package. So you don't have to worry about memorizing all these things. Autocompletions are going to be very, very critical and helpful towards actually seeing what you want to kind of build out together. So let's take a little look at some live code examples. So I have this over in my Firefox instance that we have over here, and this is playground.babylon.js, or BabbleonJS.com. And this is going to be where we're able to kind of play around and see the scene. This is just what they give you once you go to this website, and you can see how this is all web rendered over here. If we take a look about what's going on, you can see everything is wrapped within this create scene function that I mentioned at the very beginning. And this is kind of how we define what is going on. We are defining the scene itself as its own variable using babylon.scene, with the engine as well, and then we're doing a camera creation, which is really important to make sure that we're actually able to see what's going on. This one's a free camera, so we are able to click and drag and see everything that's going on. And what we're doing is we're actually assigning it to a vector position. So we have the 0, 5, -10. We can even play around with these numbers over here. So if we set that to 10, for example, and press play once again, you're going to see that we're seeing it at a different angle. If we do it 20, we're going to continue looking at different angles every single time we're changing these things. We're able to use tools like .0 as kind of helpers to do the 0, 0, 0, 0, and be able to kind of attach control to different things. So camera.attach control canvas true is going to let it equal the canvas, so we are able to click and drag just like that. We also want to add things like lights. So let me switch this very quickly back to a 5. So we can get that original scene. And the light is going to be how everything is kind of broadcast directly onto the objects that we see over here. This is a hemispheric light. There are a few different types of lights, but this is going to be kind of the most common and classic example of adding lights to your different scenes, where we're putting it directly in the sky at 0, 1, 0, and it's going to determine the angle in which things are being kind of shown, where you can even see the shadows and everything. We can kind of comment out these different pieces of code, and you're going to see that it's going to cause some light issues. You do need a light to be able to see the canvas, but we can change things like the angles. So if we change the light over to this direction, you're going to see the shadow of the sphere changed because it's now pointing closer to the other side of the sphere that we're seeing over here. You can change things like light intensity, and then you also have the actual positions of the objects we're seeing themselves. We have a sphere here where we're using the mesh builder, as I mentioned over here, but here you can see it's create sphere. We can even remove that over here, and we can determine what else we want it to be. So we can type in create over here, and it's going to come up with some examples of what we might actually want to create. So you can do boxes, cylinders, directional lights, WebXR cameras, a bunch of different things. So if we wanted to, for example, create a box instead, what we're doing here is we have the actual mesh that we're creating over here. We have the name that we're calling it, and then we're defining some of the properties of it. Same thing we had over here with the light and the camera. We need to be able to determine where we want it to go and what it actually wants to be. This is the vector position of it, but here for an object like a sphere, we need to do things like determine the diameter and how many segments are a part of it. This is kind of the same polygon physics that you might be thinking of when you're thinking of like kind of old school video games on, say, the Nintendo 64. If we reduce the amount of segments to, say, 8, we're going to be able to see that we still have a box because boxes don't require very many segments. But if we switch this back to a sphere, and switch it, we switch it over to a sphere, you're going to notice that it's a little bit more blocky. And the more we reduce the amount of segments, the more blocky and polygonal it gets. We can choose the position of it, again, just by redefining the position. We're setting variables, but we're able to redefine where these things are going by re-referencing the variable that we're creating directly within our JavaScript code that we have over here. And we're also able to do things like create grounds. So that is this little plane that we're seeing down here that we're kind of putting everything on top of so that there is an actual floor that things are being kind of based on. Finally, we want to make sure that we're returning the scene, and that is kind of the basics and how we are able to play directly with Babylon. So we don't have a lot of time to kind of go through all these different basics, so I do highly implore you to check out a lot of these different assets, but let's talk a little bit more about these 3D assets and concepts we're kind of looking at, where we can do things that require some more complicated kind of model work than, say, just spheres and boxes and cylinders and the like. And for that, what we recommend doing is loading files with things like import mesh over here, where you're able to showcase a lot of different community demos that we have on the Babylon website, or any models that you might have with programs such as Blender that are going to be very helpful for you creating the metaverse environment that you actually want to create, because you're not building everything off of a bunch of different spheres and boxes all directly piled up on each other inside of Game Engine. That's just very inefficient. You're going to have 3D modelers helping design and place things for you that you just want to import directly into your engine. We have an example of this over here, where we've imported the skull model that you can see is quite detailed, and you can look at every single angle. And this is something that you might want to be putting directly into your metaverse. But if we go directly into the community section of Babylon.js, you're going to see that there are a lot of different examples that you're going to see of things that people have built directly that you can copy the code of. All of this is open source and be able to view all of it. So you can see, for example, this, let's say, soda bottle example we have over here. You can see all of the different textures that are being imported. We have a lot of them directly uploaded via GitHub as a CDN we have over here, and defining the sizes and the scenes and all this. You can see this is a very detailed scene going on where it's showcasing the soda bottle, but it's kind of presenting itself in this larger world of a train station we have going on over here. You're also able to do things like changing colors. So we have this scene example over here where we have things like rings and cubes and spheres, all of different colors that we're able to kind of predefine. And then also do things like mouse camera navigation, switching scenes, and downloading all these tools directly within each other. So if we kind of take a look further at what's going on, we can click and drag what's going on with these different shapes. And we can even kind of click on these things. We can load screens, we can debug and see what's kind of going on by opening the scene explorers. These are all built-in tools that we have within, where we can even take a look by clicking on this tools tab over here, where we can do things like taking screenshots, recording videos, and capturing different things with RTT, importing scenes, exporting scenes directly to Babylon. So you're able to share these files, and it's going to be exactly as you see it here. That's really cool about the thing with the playground as well, where if you have something you really like, you're able to go onto this little save button over here, and you're able to kind of define what's going on. And it's going to save this file for you as a hex code, which is unique to you, where you can take this and then paste it anywhere else, and it's going to be able to reproduce that same scene for you directly within the playground. You'll notice that my light's still in its different place, and my sphere is not quite a sphere, the same way as it was, where if I just go back to the playground without that special kind of hex code that we saw over there, we're going to have this sphere. Babylon also provides support for VR and AR experiences, where you can put in your headsets and be able to try out a bunch of these really cool things directly for yourselves. It uses the WebXR framework as a replacement for WebVR, which I believe has been discontinued, that has full compatibility with headsets like the Oculus, the Index, and the Vive, that you're able to kind of create these really immersive experiences directly with them. If we go over to the playground scene that we see over here, you're going to see that we have this little goggles button over here, which they have turned into a way to see things in this immersive experience that you would see if this was actually being shown directly using a Google Cardboard, for example. I don't have that kind of proper display, so it's not going to work if you put on a headset and try to see this talk right now via one of those. But you'll notice that this is just exactly the same way you would see in something like Unity or Unreal, but all directly within JavaScript, which has been a really, really cool way we've seen a lot of developers build things directly. If you do have something like a Google Cardboard, I do recommend going over to this playground link over here. You can see that hex code right there, and you're going to be able to see how it works directly within your browser in code that you're able to see live right there. Additionally, you probably are going to want to be able to animate your characters as you are creating your own metaverse experience. And for that, we use render loops to modify models. Scene.onBeforeRenderObservable is going to be able to kind of create a loop for your characters that they're continuing to do in action, both in the actual model's kind of look, but then also in things like position. If you want to move your character, or if you want to make your character emote, you want to be able to assign these to, for example, key presses or mouse clicks, so that you're able to have full interactivity with your character itself. So we can go over to the live demo we have directly within my Firefox instance once again, where we're going to be able to see this girl that we have over here, and we see all this code, where a lot of this is set to cameras and lights, but we can go down a little bit further and we can see the character itself, and we see this rendering loop over here. The rendering loop that we see directly right here is going to allow us to assign the WASD keys to let her move in the direction we want her to move. We're able to turn, we're able to go backwards, and we're able to do things as well that don't require any movement. So if we just want to change how the character's animation looks by, for example, let's say make her dance, we can press a character like B, and it's going to be able to load a different animation for that character model, so that we're able to just kind of fully immerse with the character itself and be able to make the character really act like how we would want it to be. This can easily be mapped to other things, like, for example, if you're using controller because you're doing a VR experience, you can instead map it to the controller inputs instead of keyboard inputs to emulate that more similar experience that you might see over there. Let's talk a little bit about using videos as a texture. I think one of the best parts about the metaverse is being able to use actual content and being able to share it among a lot of different people. And oftentimes we do that via videos, where this is still an HTML5 based thing. We're able to use things very similar to a video object, but we're instead putting it as a texture for an object that already exists within Babylon. And this is done via Babylon.videoTexture. This is essentially the same thing as you would be using within an HTML video, where you can play it and pause it with similar functions. And you can also assign these different commands to different GUI buttons, as you see in this image over here, where we have a video that would be playing, and then you can change it from playing, pausing, and muting directly within the interface that you have in your Babylon workspace. We can take a look at what this code might look like by going back to our instance over here and taking a look at this video textures example we have over here, where we have this menu button over here, which is going to enable us to take a look about what's going on, where we can play the video directly itself.
But what about the city of the day after tomorrow? Say the year 2000.
We can mute it, and we can also pause it. If we look at the debug section over here, we can see all the different textures that we might want to be seeing. So we have the video texture over here, which is that video file that we have over here, and we've assigned it directly onto the cube that we have kind of defined over here. We see it on all these different faces of the plane, and we're able to just kind of understand directly where it goes. I can go and open my VS Code instance that has the code that defines all of this, where we see the same things. We're creating the scene, we have the light, we have the ground, and we're setting the video texture over here on a plane. So a cool little thing we have here is we're able to better set the scale and something that makes sense for what video you're using here is. So if you don't have a lot of bandwidth, you might not be able to have a huge video. So what we want to do over here is we just want to set a 16:9 because that is the kind of most common dimensions we see for modern videos these days. And we're also setting a scale so that we can properly divide it by the scale we want it to be done on so that it best fits and best renders on the environment that we have. This is going to differ depending on how powerful your hardware is, but for this scale where we're working directly on a laptop, we do want to downscale it by kind of a factor of 3 over here. We can also are able to set the options of height and width and to decide to, for example, do things on both sides. This is all here by doing a mesh.double side. Otherwise, it's only going to show on one side of the pane that we have created. Then we have taken the video file that we have locally directly over here, and we are setting that as the video material, and we are putting it on a loop and an autoplay, and then have a pause function as we want over here. We're able to do things like put it directly on the cubes and just kind of place it wherever we kind of want it to be. This isn't the only way we can actually interact directly with these videos as well, however, as these don't have to be directly saved in your browser or in the kind of server that you're running this game engine within, where you can also do things like live streaming. So Dolby.io has a live stream product for live content, and this isn't limited to your existing video files. This is all in real time. You can get your API credentials and have a free trial on our sign up page, but what you need to know here is that the video texture accepts streams too. It doesn't need to have a set file for it to play after. It can accept a live feed, where if we're assigning the source object to the stream URL that you have from Dolby, it can actually enable this real-time broadcasting. And this is great for things like events and concerts and lectures and all these different things that require live interaction within an audience to go and see. So let's take a look at what this code is actually going to look like. But first, we can see a demo. So on this same scene that we have over here, let's close this debug menu that we have going over here. I can go over to our Dolby dashboard over here. I've already created the stream token and everything, so I'm just going to go and click on broadcast right now. And what I'm going to do is I'm going to click start right now. And you're going to see that this is started right now. We can see a number over here. This is just the live camera feed right now, so this isn't the actual stream. But if I go back over to the video texture over here and I click on stream, we're going to see that this is the live feed that we have over here. You'll notice that this is a little bit delayed from the actual movement that you see in my webcam over here, but it's pretty darn quick, which I think is pretty impressive. So it enables just kind of the full experience to any people who are directly within this instance to be able to see what is happening from that game stream. So I'm going to pause that. I'm actually going to close this window over here so I can show you what is actually going on directly with the code. So this is the same code that we just saw with the video texture over here. But what we're doing is we have a little helper file over here called stream.js, where I've already inputted a bunch of different credentials. I'm going to be removing these credentials. Don't worry about that. But what this does is it allows us to connect to our servers at Dolby.io so that we can access that stream URL that we are able to see. So what we're doing is we are setting a stream class to allow us to kind of connect into this streaming interface so that we can connect and be able to get all these different tokens and properly authenticate directly in here. So then if we go back into the video texture we have over here, and I do a quick little search for Dolby, it's going to let the URL that we're setting the video focus to our streaming URL broadcast that we have over here, where we have the proper token, stream name, and token ID, so that we're able to access it in the first place, and also get the correct stream that we just made happen in the first place. This then functions exactly the same as the video that we were doing before, but instead of it being pre-saved and pre-stored within your server, you're able to generate live content on the fly. It doesn't need to just be something that's pre-made, which is really good for kind of live instances, such as a concert, or if you're playing a game together with a bunch of friends, that you want to be able to kind of get that real-time instance of seeing what's actually happening within that stream. Additionally, you can also add in spatial audio directly within live communications. where if you have multiple people on a server instance at the same time, you probably want people to actually sound like they're in the position that they are in relative to each other. Where most of the time, if you're on a kind of video meeting with somebody else, you're hearing everybody from the same direction. They're just coming out of your speakers the same way as everybody else on that same call is from each other, which doesn't really emulate the metaverse, at least not in my opinion. And what's really cool is that Dolby.io has a solution for this, where we have the ability for you to add on real-time communications, where you're able to have a voice or video call with multiple other people, but then also take in consideration where their positions are in relative position to each other, whether it is on a 2D pane or even in 3D example, as we see over here, and make them sound like they're coming from that direction. So this is going to be really, really useful for letting people get into the areas that they're actually participating in and making them sound like they're coming from directions and making them so they don't broadcast in your speakers if they're too far away from you. And we don't really have enough time to showcase this right now, but what's important here is that because we already are taking in the positions of all the different objects that we've been placing in Babylon, remember the little demo that we had over here of all the different donuts that we had over here where we're changing the positions. This is updating the positions directly within the code, which we can then feed over to our SDK that's keeping track of the spatial audio communications and say, all right, this person's over here, this person's over there, and then change where they're coming spatially in all those different areas. So it's not just a set position, it's dynamically altering people based on where they are moving within your metaverse that you have then created. We have an example of a customer who has actually been using this for their own metaverse creating website, odyssey.stream. You can access yourself, which is where the screenshot came from. They're allowing people to build their own metaverses using the spatial audio as a way to kind of be a big difference maker in terms of letting people actually sound like they're coming from where you see them, especially if you're in a VR headset. That's even more important to make sure that you're kind of really pretending that you're within those eyes that you've put on and being a part of that. And it's amazing that you can do this all within JavaScript. There's no need for these kind of super high-powered dedicated game engines. You can do it all via the web. As I begin wrapping things up, this is all the tip of the iceberg when it comes to Babylon.js, where I do highly encourage all of you to do your own research when it comes to figuring out what works best for you. Definitely taking advantage of looking at the community archives to kind of both get inspiration on what you might want to build, but then also get access to tutorials on how to start building something that you want to build yourself, on models that you might want to copy yourself and use in your own projects. Taking advantage of things like Blender resources as well to kind of get access to all these is all just really the beginning of getting the journey of being able to build things in Babylon. Like, remember, Minecraft was built in Babylon.js, and Minecraft has endless possibilities of what you can do with it, so there's really endless possibilities in what you can do directly with Babylon. We have a deeper example of all these different demos that I showed off to you today at this bit.ly link that I have over here, which is going to bring you directly to a GitHub repository where you're able to do a self-started workshop of all these yourself, so that it isn't just kind of me talking and telling you exactly what is going on and why it's important to you, but you can do it on your own time and get kind of down and dirty with the code yourselves. And then if you do want to integrate the streaming or spatial audio solutions directly into your Babylon.js instance, check out our documentation at docs.dolby.io for more information, where we'll happy to get you started and kind of integrating these next level communication resources into your applications, into your metaverses, and kind of building what you want to build. And finally, thank you. I hope you enjoyed this. I hope you learned something new. I'm really excited to see a bunch of things that have been built. If you do have anything cool, definitely tweet me down below. You can see my Twitter handle at Wing of a Griffin, where I want to see what you're building, what you're interested in, and if you have any questions. I'll be doing a live Q&A right after this. This is pre-recorded, but I hope you enjoyed this. Thank you so much, and I'll catch you in a couple seconds.
So thank you, Griffin, for this amazing content. We're going to jump to Q&A questions, but before to move on, I'd like to invite Rameez. So Rameez, welcome to the stage again. And we want to give you like 5 minutes to finish like your talk about web components and their applications. I know you need to be more specific about the limitations, so go ahead, the stage is yours.
Okay, thank you so much for giving extra 5 minutes. And yeah, I will just jump straight into the limitations. So there are some limitations of using web components. Number one is, of course, it's not supported on legacy browsers without using polyfills. In some cases, you need to support IE 11, especially if you're working in government sector. So you have to make sure that it works on all the old browser and well. So you want to make sure that you are adding those polyfills and also testing thoroughly that nothing is breaking on legacy browser. Number two is learning curve. Of course, web component is not as famous as React or Angular, so it's hard to find developers that are experienced in that are experienced in web component. And if you start in web component, then you will face some learning curve, obviously, because there are not many resources available. Number third is automation scripts. So if you have an existing existing automation scripts that are working for you in your system and you want to migrate to web component, there is a possibility that those scripts will fail, because if you have a script that clicks on a button, that might not work on the button that is built using web component because of Shadow DOM. So you have to make sure that you are considering this factor and making sure that updating your scripts once you are done with migrating to web component. And yeah, I've attached a demo at the end. You can play around with it and see the code on GitHub. And that's all from my side. Thank you so much.
Thank you, Rameez, for this closing session. So I'm going to invite right now Griffin. So welcome, Griffin, to the stage. And
hello.
Hello. So I'm going to invite also Deepa. Hi, Deepa.
Hi there.
How are you? Hi there.
I am awesome. Thank you so much.
Thank you, and Rameez, of course. So thank you for your amazing content. I was really happy to be connected with all of you. And I have several questions for our audience. And I'm going to start with Deepa. So Deepa, this is the first question we have. So do you use MSW with the Storybook?
What is MSW? I have no idea.
If you don't have a clue, you can say.
I'm honestly, I don't know what is MSW here mean. Can somebody tell me what is it? I can then.
Yeah, so let's jump to the other question, and probably they are going to resolve that question in the chat. Don't worry. So, Deepa, how do you share the components across different projects? Do you clone the repo with components to each individual project, or what is your methodology?
It depends on how your project is structured. If you're working with larger teams, then you might have a one repo, and then probably you will collaborate with different teams based on how you set it up, because we work across different teams at Adobe. And I think I gave an example of how all these components are laid out. It's an open source project too. So it's a big, and it depends on how you are setting up on your side. And you can share it across different teams. And that's the whole idea of Storybook. You just can share it across different stakeholders inside your company. I hope that answers that question.
Yeah, thank you for your answer. So I know like Rameez know what is MSW, and share with us like a Versal app link. So if you
I haven't. Oh yeah, this is an add-on that I have not tried out. Probably there's a lot more to Storybook. I just picked up the main things that I wanted to give an overview of how you can use it for performance and accessibility and testing as well. So there are lots of add-ons that you can add with Storybook and play around with that. And they've also released a new version of Storybook. I think it was this week sometime. Storybook version 7, and they also support internationalization. So, yep.
Thank you so much, Deepa. That's pretty close, that question. So right now, Rameez, the turn is for you. So from on A11 wide perspective, is Web Components supported by these tools like screen readers, Aijaz, Envy, VoiceOver, VA?
Okay, so as far as I know about this, I can be wrong. I can be wrong, but I think it's going to work if you define your ARIA labels and all that attributes, if you define them on your web components. And again, if you are extending the existing web component, or if you're extending the existing HTML tag, let's say you are extending div, so it's div is accessible, right? And you can define ARIA label on div. So of course it's going to work on your web component. Again, it's take it with grain of salt. You can test it yourself. I've never done that. I've never done this. So I'm just giving my opinion on the fly right now. So yeah.
Of course, you can stand the experience of what you show us here. So yeah, it's a pretty far answer. So Griffin, jumping into your Metaverse talk. So do you know the open source Metaverse, and if you can recommend or could recommend some project across?
I mean, like, so a lot of, the open source metaverse is such kind of a broad world and experience out there. So specifically with Babylon, the Babylon workshop is going to be a lot of that open source metaverse that I was talking about during my talk itself, where you're going to have a lot of the user and community contributed assets, components, and everything that you can work directly with as kind of a starting off point and breaking off directly on there, because all the code is there and intended to be shared and used across a bunch of other people. Though I would also say, like, definitely make sure that you take a look at the community in other ways as well, which can be things like looking up GitHub projects. Like maybe they're not directly uploading it to the workshop, maybe they're putting it directly on GitHub. Maybe it's on YouTube. Maybe people are talking about it on Stack Overflow. I mean, people are talking about these types of components all over the place. You can even like kind of look even areas like Blender communities of people making these different 3D models to actually not necessarily just for Babylon, but for these different communities, and they're being shared all over the place. So I am a big open source advocate, and I think the amount of resources out there are so many. You just have to kind of look for them and also contribute yourself towards them because they exist. But kind of the beauty of open source is that they aren't centralized all into one owned company. You gotta have to find what community best fits what you're looking for and what your needs are.
It's all about community. Thank you, Griffin. So right now, the turn is for Deepa. So Deepa, what do you do if component needs an improvement? How do you update it in a Storybook and in all projects where it's used?
That's why you build in one I did say that you build in one place and it just reflects on everywhere, right? You are working collaboratively in a in an environment where you have to, if you have to change, that's a whole point. If somebody has to utilize one of your UI component, yes, they can still go ahead and use it, customize it according to their teams. But if you see no company wants to use their UI components differently in different pages. For example, we have at Adobe, we have Sparks page, we have Fonts page, we have Creative Cloud space. We use this, same UI components across all those pages to look, to do the same feel like how you have it across the company, right? You could probably update, but if you update, make sure that you know what you're doing so that it reflects on other pages too.
Okay, thank
Hopefully
you
that
for your answer. Yeah, definitely do. So the next question is for Rameez. So create custom element with extend div, like div is equal to SDF, still is a shadow DOM or in main DOM.
So it's completely up to you how you, so it's not going to make any difference if you are extending an existing component or defining a new web component. It's up to you. If you are defining a shadow DOM inside your web component and rendering everything inside it, then it doesn't matter if you are using div or whatever component. It's just going to work like that. If you are not doing it, then it doesn't. Then your HTML is not going to be rendered inside the shadow DOM, but rendered like a normal DOM. So it's up to you. You can, you can turn it on and off. Yeah.
Okay, so we can jump to the next question, also for Rameez. So, what about when you use the important keyword? Can it override the shadow DOM?
Nope. Like you can do whatever you want, and it's not gonna do anything on shadow DOM, unless you have a shadow DOM in open mode and you extract it with JavaScript, and then you override the. You have to go extra mile, like you have to write a script to override the CSS inside Shadow DOM. It's never gonna override by the keywords available, by the CSS keywords available. Yeah.
Okay, thank you. And now the turn is Deepa. So how would you organize code with the stories? I don't like to have stories in dedicated folder. Why no storing component, test, and a story in one folder?
You can set it up as per you want, but then if you are working, this tool is mainly for if you're working in a large enterprise company or a company where you use a lot of UI components together. So if you want to separate it out, you can still go ahead and do it. You can customize that as per your needs because this is going to be only working in your environment, right? So how you organize it, you don't want to organize it as stories, but then it has to be somewhere inside your React or any framework application that you're using, either inside of your React or your Angular, anything, but you have to use it inside your source folder. Okay, otherwise, it won't work. Otherwise, it won't. And also, you have to mention at stories.js. Otherwise, Storybook will not, as I said in the configuration file, it looks for those files in the main.js for Storybook to basically show the UI on the playground.
Okay, thank you, Deepa. I'm going to jump to Rameez again. So it is possible to create a web components by creating a class that extends HTML div element instead of HTML element. If yes, it is needed to explicit extend div in the define function.
It's a good question. I think I will agree with the second point. Like it is explicitly that you have to extend the div explicitly in the define part. Even if you extend it, I think it's not gonna work. But you can test it. Yeah, I'm not 100% sure about it. Yeah.
Okay, and we have two more questions for Rameez. And before we go, I want to give a little space to Griffin to tell about more about Babylon.js. So Rameez, how supportable are all those web components, Shadow DOM, HTML templates? It is something that adapted by all major browsers.
Yeah, so as I wrote in the article, like it follows the HTML web specification. So that and all the that's why we have a specification in the first place, so that all the browsers follow that specification. Otherwise, you can have your own browser and you can have your own HTML, but that's not going to work. Like that's why we have a standardized. Let's say in the case of JavaScript, we have ECMAScript. So if you want to release a new functionality in JavaScript, it has to follow ECMAScript specification. Otherwise, it's not going to be acceptable by the dev community. Same goes with web component. It follows the web specification. That means everything from now on, or all the modern browsers and the browser that's going to come in the future, they have to support web component. Unless they change the specification or decide to, deprecate web component altogether. That's going to be a news, and you will know about it. So yeah, for now, every modern browser support web component.
Okay, and the last one is, so will you implement all components with Shadow DOM inside?
That's a good question. I will say no. I will not implement every web component with Shadow DOM. I will only use Shadow DOM where I want to restrict the CSS, where I don't want it to render differently in different applications. Only then I will use Shadow DOM. Otherwise, if that's not required, then there is no point of adding extra complexity in your component, because I think that's where the value of Shadow DOM lies, that it's going to lock the style. If you don't need that, then you can have web component without Shadow DOM.
Okay, thank you so much for resolve all the questions. And I think, Griffin, you have few questions, but to be fair, I like to invite you because I really appreciate your talk. So I really invite you to share like the repo and all the amazing links you have at the end of your talk in social media, and please tag Geekle. And we're definitely going to follow browser-based metaverse with Babylon.js. So thank you so much, Griffin, Deepa, and Rameez for your time and share this knowledge, your knowledge with the community. Thank you so much.
Thank you.
Thank you.
Thank you so much. Thanks
this.
for having us.
Bye-bye.
Bye.
Marian, good evening. And we want to say thank you for all our moderators, speakers who will be with us today. We have an amazing day. We have a lot of interesting information. Thank you, Marian, that you at the end of our first day, junior day. Yes, Nick.
Yeah, thank you so much for moderation for this amazing Q&A session, and I hope to see you on our future events. And also, thank you so much for being a program community member. Yeah, I also need to mention that. Yeah, thank you so much for
Thank
helping
you
us.
so much for your time and give me the honor to present these amazing talks. So I really enjoyed this Global Summit, JavaScript Summit 2022, and it's a pleasure to be with you and Geekle in this kind of event. Thank you so much. Have a wonderful day.
Thank you,
Bye.
Marian.
Bye. See ya. Okay, so that was the junior track of our JavaScript Global Summit 22. As we mentioned at the beginning, this is our first strictly JavaScript summit that's not dedicated to React or Angular and stuff. And in my opinion, it went pretty well, but this is not the end. Tomorrow we have the senior track, so I will be waiting for all of you who have tickets. And yeah, thank you so much for maybe some of you sit through the whole thing or maybe join later. Like I said before, everything's going to be recorded, so make sure to check out the talks you missed. And we'll also send a feedback form that will let you send a feedback about the conference, awesome talks in detail. So we would really appreciate any kind of feedback from you. But for now, have a nice night, evening, morning, wherever. We'll see you, some of you at least, tomorrow.
Yeah,
Bye.
see you tomorrow. Thank you very much for this day. Bye.
Bye.